Are we all here? We are. Well, the door's shut anyway, so I'm going to assume we're all here. How was lunch? Good? Good? You like the food? Yeah. I mean, this man up here is one of the people responsible for the meal you had today. So again, an applause for Symmetry. Now, before we kick off a little bit, you might notice in my hand here, I have a little D-Man shirt. So what we're going to do in between talks is have a little bit of a competition, which is basically answer the questions I put out. And the first person to get it right gets themselves one of these shiny D-Man t-shirts. All right. So this is the first question. First person, the hand I see, I will get them to answer it. What was the original name of the deprogramming language? There we go, Attila. Mars, there you go. You've got a D-Man shirt. If you need a different size, we've got plenty back there. All right, so applaud him for knowing the name, I guess. Woo! Okay, and with that, it is time for our keynote speaker to do his presentation. So, Laith Isaac. Round of applause.
Thank you. Very much appreciate the opportunity to host everyone on behalf of Symmetry Investments. It's an honor to be here. I'm curious to know where people have come from. Who here is from Britain? From Europe? The States? Africa? Have I gone somewhere? Asia? Great. And who uses D at work? Who doesn't but would like to? Okay, that's interesting. So I'd like to share our experience of using an emerging programming language at Symmetry Investments, and then to explore together anything that might be useful for the broader development of the language of the community. I'm responsible, amongst other things, for the technology function as a whole across Symmetry, but I'm speaking for myself here. My career including at Symmetry has been in the alternative investment management domain. What does alternative mean? To me, alternative has the same connotations as it does for when you use the word alternative applied to other creative fields. Alternative music, alternative media, alternative literature. So I think that in our industry, in the money management industry, it means that you can avoid doing the stupid things that very smart people are forced to do by their context. So if everyone does the same thing, and you understand why they do it like that, but you can see a better way, then in the alternative domain, you have a choice. You can create a new context where it's possible to do things differently. That's what I think the word alternative means. I think for a while in our industry, we forgot that. And I think I hope Symmetry is part of a new wave of creativity that recognizes that if you open your eyes, as Andrew says, there's treasure everywhere. Where does life have its beginnings? I think beginnings go back a lot further than people generally recognize. So I'm going to go back to 2004 when I was co-head fixed income trading for a large American hedge fund in London. I should perhaps say I'm not a programmer by profession. I started programming in 1983. My first open source, as we would call it today, contribution was to a routing algorithm in Tom Jennings' FIDONet in 1989. I discovered economics and human behavior is, for me, a much more challenging subject than the behavior of computers. So for most of my career, I've been a trader. So back in 2004, the groups I worked in had started in 1999 with limited resources. Things were improvised in a hurry. Trading tools were built in a combination of C++ and Perl. And the fascinating thing about financial markets is that they're always changing. So whatever you do and however you do it, if you're going to be working in the technology aspect of money management, it's important to be able to adapt. So the only company I worked at back then began his own career in programming, and he read a lot on the internet. He recognized that that Perl is often a source of considerable technical debt, which I suppose is true. So the diktat came that everything was to be rewritten from Perl to C++. Consequence being that we had no new tools for quite some time. And by the time it was finished, there was no one left at the firm who wanted to use these tools. So there's nothing like, for learning, there's nothing like experiencing something personally for it to really have an impact. And it stuck with me. I didn't know what the answer was, but I knew I didn't ever want to be in that position again, of having to choose between the productivity of rapid prototyping and the seriousness required for managing other people's money within an institutional context. I found at Symmetry Investments Fund Go is 38 years old. He's a very unusual person. I came to be involved at Symmetry initially just as a consultant working from my home office. I was going to hire a programmer from the D community to help me, John Colvin, probably familiar to quite a few of you. Funk said, he's 24. Don't you think you'd be better off with someone with more experience? So I sent him a link to one of John's talks, just the abstract. I figured he'd read the abstract. But no, he watched the whole thing. He watched video. And the next time we spoke, why haven't you hired him yet? I said, Fung, because we haven't yet got our own contract signed. So anyway, we went ahead with that. So Fung has some very interesting ideas about business, and one of those is the symmetry win-win principle. And the win-win principle is different from the Anglo or American conception of win-win. It's a symbol that stands for many things. One of them is about the dialectical reconciliation of seeming opposites. And linked to that is the idea of a refusal to accept premature compromise. What does it mean to accept premature compromise? Well, if you compromise between two options, implicitly you're assuming that you have to choose. In economics, there's an idea of an efficient frontier. By assumption, you're at the optimum. Since you're at the optimum, you cannot make any more improvements. You can't get one good thing without sacrificing another good thing. So if you're a worker, you can get paid more, but only if you work more hours. Or you can work less hours, but only if you're willing to get paid less. The example there, if you're at war and you're expanding social spending, then after a certain point, you can make more guns, or you can make more butter to feed people, but you can't do both. But that's an assumption. And both the programming itself and for an early stage firm, and Symmetry was founded in 2014, so we're still in the early stages. We've gone from 20 people in October 2014 to 150 odd people today. So for an early stage firm and for programming in general, and bear in mind that we're a firm in the alternative money management business, which is highly dynamic, it just isn't true. It just isn't true that we're nice. You can't have been in any kind of optimum before, because surprise is an indication that you're in a context of Knightian or radical uncertainty, meaning you couldn't have known the things you needed to know to optimize. There's a joke told by Kenneth Boulding, an eminent economist. A physicist, a chemist, and an economist are stranded on a desert island with no implements and a can of food. The physicist and the chemist devise an ingenious contraption to open it. The economist says, assume a can opener. But if you're doing something very practical, as we are, it's a very practical business, then it's supposed to be quite careful about what you assume. So when I hear you have to choose, you have to choose. You have to sacrifice one thing for another, I get very suspicious, Why do I have to choose? I'd like to have both. I want to have my cake and eat it too, and it's quite possible that I can. So what kind of choices do we have to make in technical decisions? If you want productivity, write Python. If you want performance, write C. You can have expressiveness or readability, modeling power, but then it'll be very complicated. And you want to, on the other hand, you want to be able to adapt to change alongst dimensions you didn't expect to have to change. And you don't want to be stuck with code that's sort of very brittle, so you can't change it when something unexpected happens. So which of those are most important? I mean, they're all very important. I don't want to have to choose. There's another idea from economics about the theory of the firm. Economists often assume that firms are profit maximizing. Who here has worked in a firm? Have you ever seen choices, behaviors that have nothing to do with what's best for shareholders and deviate from rationality? Like, just obviously can't be rational, just because of, age-old human fallibilities, weaknesses, and so on. Who here has worked for someone else and then run their own business or been part of a family business? Did you try to do things differently from when you were an employee? Try to avoid suboptimal outcomes that you just had to learn to live with when you worked for, a large firm? So economists call the deviation from economic rationality, profit maximization, that takes place when you have managers who aren't owners. They call it X inefficiency. X because, who knows what to call it? Naming things is hard. What kind of deviations from rationality are common? Well, one of them is that there's the best decision for the company, and then there's a decision that will make you look best. And they aren't the same thing always. Life is risk. When Brian Acton decided to start WhatsApp, it was a pretty risky decision. It might not have worked out. Most people would have said the odds were against it. But it turned out pretty well for him, even though he seemed to increase his risk by using a weird language called Erlang that wasn't exactly well known to the suits of his money. He sold out for $19 billion to Facebook. Was it a good decision to start WhatsApp adjusted for the risk of failure? I'd say so, but if he had failed, what would people have said? For Brian Acton, probably not many people would have said anything because he wasn't that well known in the industry. Actually, he just before he started WhatsApp, he'd applied to Facebook and they turned him down. Is that the world's most expensive hiring mistake? But consider the same sort of decision to take a risk by doing something that might not work out in a corporate context. If you choose to do something that's unconventional, according to the ideas of people surrounding you, it means it's going to be hugely risky. Even if, objectively speaking, a neutral observer with a considerable degree of expertise would judge it was actually quite a safe choice, if the people around you can't see that, then for all intents and purposes, it's a risky decision. And if you do something unconventional and fail, then in most contexts, you are in a lot of trouble. How could he not have seen that X would be a problem? Does anyone else use this thing? It's not on the list I got from Gartner of best practice industry solutions. For people who don't know, Gartner's their sort of enterprise technology consultancy. On the other hand, suppose it works. What then? You might get a bit of recognition and an increase in pay from success, but it'll be incremental, and it's unlikely to compensate you for the social risk involved if it didn't work, given that you made an unconventional choice. So if I had the role of a regular manager at a company that thought very conventionally, then even though I'd hold the same views about the commercial benefits of it as I do today, I do not think I'd have used to do much at work. It's just not worth the inevitable criticism and social consequences sticking out. Maybe quite a few companies are like that. Maybe many companies, maybe almost all large companies. But plenty of companies are not like that. Small and medium-sized companies are very important in the global economy. In the States, small businesses create 62% of net new jobs. But the people that talk, the impressive people you hear from at S&P 500 companies, the average lifespan of a company listed in the S&P 500 on the stock market is less than 20 years. Now, it's not that small and medium-sized companies are necessarily open to doing things in a way that makes sense but is unconventional, but quite a few of them are. Large companies tend to have bureaucracy, and bureaucracy means committees. And it's very difficult to be a relatively early adopter of a technology that doesn't look compelling enough based on a box-ticking contest. D is plastic. That's interesting, Mr. Ishaq, but what's your evidence for that? The Goldman Sachs used D. Symmetry is a bit different. We try to think about decisions within the firm from the point of view of an entrepreneur or an investor or a trader. So the first question should be, what would I do if I owned the business? Now, in practice, not everyone owns a business. So the second question should be, considering the practical reality, how can I explain the social factors beforehand and figure out a plan to address them? After I became involved in symmetry, I did something I would never recommend to anyone else in my position. We had a bunch of risk reports written in SQL. Understand that a risk report is not just any old report, it's something absolutely critical to manage money. You need to understand the risk of your portfolio. I'm pro-SQL. I mean, it's a pretty good language for its domain, but the domain of financial market risk calculations reporting, that's something more specific than what SQL was designed for. So SQL is one thing, but we had VBA generating SQL with string concatenation. Well, it sounds awful, but then VBA's loops. No, we didn't use loops. It sounds... So, one report was 10,000 lines of copy-paste. So we no longer ourselves understood the report. It was a drag in adapting to change because it was so difficult to make changes. What to do? Well, it's easy enough if you have financial resources to rewrite it, to rewrite a report like that. Just find someone who will hold their nose for money, figure out what the old one was doing, and write it properly. Any language would have done. SQL, Python, QBasic, well written. But how do you prevent the same thing happening again? That's not so easy because practitioners are not programmers. One interesting question is, how would they feel if you introduced them at a party as a programmer? So they just have a different set of goals. They want to get work done. And they're writing amidst very difficult constraints. I mean, highly intelligent people, but they've got a different set of constraints from the ones that we might be used to most of the time. So what to do? Because you could rewrite this in something else, and if that was it, what would stop the same thing happening again? So I did the indefensible, and we wrote our own domain-specific somewhat functional programming language, symmetry integration language. Language design. I suppose it's not a field you just pick up. In truth, we had no spec, no documentation, no project management. John Colvin worked part-time in it. Dmitry Popov worked for a couple of months here and there. Probably the very early stages that was useful, needed refining, was 1.5 man-year total investment. I read Force and C early in my teens, and that was one of the hardest programming projects I'd done relative to my capabilities at the time. And a threaded interpretive language is easy because you build it up in itself from starting from quite a low level. I wasn't going to do what was a reasonably ambitious project for us at the time, given our resources, manpower. I had a dinner with Bastian, the naval architect, and I heard how he was using Pegid to translate extended Pascal to D. Well, Bastian's very smart, but surely given my own capabilities, it must be possible to manage this much humbler project of writing a little DSL. But writing your own language is one thing. Writing a language and a standard library is another. There's absolutely no way we could have managed to write a useful standard library ourselves from scratch, not given the amount of people we have compared to the amount of work we have to do. Steve Jobs said, good artists copy, great artists steal. So we just stole Phobos. So the code itself is not super interesting. We just looped through the symbols in std.math. That's just one example, and registered them. So we wrap the function up in an algebraic and register it in the symbol table at startup. I mean, the previous one is actually, it can be more automated thanks to a Tillinese auto wrap. But it's quite easy to do, so the full auto wrap isn't necessary. So symmetry integration language, SIL, is in production. The bulk of the reports have been rewritten in SIL, thanks to Peter Robinson, who's sitting at the end there, and Pierre Mikotis, as well as our risk team. That 10,000 line monster is now around 1,000 lines, most of which is configuration data, and it's easy to understand, reason about, and change. The language itself is pretty small, less than 5,000 lines for the language, and lots of static if and static for each. Code sample there. It's pretty straightforward. Looks rather like D, except you've got a pipe operator instead of a dot. So there's a sneaky purpose as well, not really sneaky, just indirect. And that was a question of cultural transformation. So by moving to SIL and by working with people who have the values and culture and practices that we take a standard in the D community, we've introduced version control, code review, testing, practitioners understanding declarative programming, and there's been an integration between practitioners and programmers, which would have been difficult to achieve other ways. A chap called Peter Thiel, you might have heard of. He was the CEO of PayPal, during the dot-com crash, with the first investor in a little company called Facebook. Peter Thiel says that we've been taught that truth is conventional, but it's simply something that people agree on. What's important is to discover a new truth. And all great businesses, he says, are built on secrets. But how do you find out secrets? How do you come up with your own secrets? So another chap, who I've learned from a lot, called Tom DeMark. He's a financial markets guy, not really a programmer. He says the best secrets are hidden in plain sight. The best secrets are hidden in plain sight. So the thing about the internet is you can Google anything. What happens to the value of, if you increase the supply of something, what happens to its value? It's probably going to go down a lot. So knowledge that can be captured in a document, it's going to be pretty hard to build a business on that. But there's another kind of knowledge, which is called inarticulate or tacit knowledge. A chap called Polanyi wrote a few books about it. One of those kinds of knowledge is know-how. It's know-how. So that becomes more valuable if the supply of information increases, because information and know-how are complements. So if information gets cheaper, you want more know-how because it's much more valuable because information is cheaper. There's an idea called structural hole theory. A structural hole, if you think about a network, so who knows who, just think about your friends or the people you talk to in programming. A structural hole exists in a social network when there's no direct contact between two or more entities. And they've done a study of getting a job. If you think about, the last time you got a job, did your friends, the people that you know most of all, were they helpful? The chances are not, because your friends mostly know the same things you do. I mean, that they've probably told you ages ago. So So it's more like a friend of your sister's cousin that where you're likely to learn valuable things from. You're much more likely to hear valuable information from people at the fringes of your network. So there's a chart here that I won't spend a lot of time in, but the same thing sort of applies to industries. Because does Goldman Sachs know something, Goldman or Morgan Stanley or anyone else know something incredibly valuable that I don't? Well, they might know some things, but when it comes to knowing how to do things, maybe not, because for just these reasons. So there's value to being a bridge between two worlds. Behavior, opinion, information is homogeneous within a group. So a group that's distinct has different ways of doing things. You know, some of them may be crazy, just different, whatever, but some of them actually, in that group, they know just the thing that you benefit from learning. So you can think of this as arbitrage. Arbitrage is buying something, buying low, selling high at the same time. So if you bridge structural holes, you can learn things you can learn secrets, things that are valuable for your business or for whatever it is you're doing, and give you choices, insights, the ability to see possibilities that you couldn't have gotten any other way. People say with D, you know, like D needs to decide what it's for. I mean, I know what Go is for. You know what Rust is for. What's D for? I just took the first 9 companies on organizations using D. What do they have in common? I mean, they cross. It's difficult to say what industry these were adopted by. Now, whether or not in itself that is a good thing or not, there's a benefit from that, which is that you have the benefit, you have the advantage of being able to learn from many different kinds of people that you wouldn't normally talk to. So much for integration language got started because I happened to have dinner with Bastian. Bastian's a naval architect. I suppose I knew that there was such a job. I'd never met one before. So I think that's one benefit of adopting D that just I haven't heard many people talk about. I'm Marie Sachet. I don't think I'd have gotten to know him a little bit if it went through D. So it brings people together who are deeply interested in programming, and value certain things. So I suppose there are other aspects that characterize the D community. I think that, sorry. I think we're in an age where there's been a loss of ambition, a loss of courage. People think that programming is just about strapping together different libraries with glue code. And what are you doing that for? There's a library for it. So although this isn't unmitigated good, I think that there is this idea that it's just code. So Steve Jobs talked about this in a different way. He said, life can be much broader when you discover one simple fact. Everything around you that you call life was made up by people who are no smarter than you. In some cases, a bit smarter. No smarter than you, and you can change it. You can influence it. You can build your own things that other people can use. Once you learn that, you'll never be the same again. So there's some merit to that virtue, to not being put off by having to write code, by having to figure stuff out, that can be very valuable for us in the data business, where the problems aren't defined. It's market opportunities change, and we're a younger firm, so we've got to put things in place. So that's this kind of, it's a resourcefulness, a just not being deterred. There's an aspect of sort of just big sheer grind persistence, and there's an aspect of daring. Walter wrote his first compiler after someone told him, "Who the hell are you to think you can write a compiler? A compiler is for people not like you." Well, I think the spirit of the community is set by its founders, and that's something that's quite noticeable here. So I think the unexpected benefits of D, and I'm not going to dwell on the ones that probably we all know: courageousness, resourcefulness, one, information arbitrage, just becoming in contact with people who do interesting things in other domains. The talent, I think that obviously there's a wide variation in programming ability, and the community is sort of self-selecting for people who are quite able. Modern environments, you tend to have data from many different sources. They're almost the same, but not quite. So for marshalling and type conversion, glue code without having to write it manually, having to have all this boilerplate, these have been quite good for us. And then the sort of adaptiveness. Why does plasticity matter commercially? What's the dollar value? Well, if you're in an environment where you know how things are going to be in 2 years' time, 5 years' time, what does it matter? You can just put a facade around old code, whatever. But if you're in a different kind of environment where things are changing all the time, then you need to adapt to change. And the easier you can make it, the faster you can move, and the better it will be. So the commercial benefits can be quite high indeed, because if you want to launch a new strategy, if you can do it 2 years before everyone else, then you have a considerable advantage. So sort of time for a first version that you can sort of begin to use might matter more than the total cost of time. I told one CTO in the industry about a sentiment analysis project I was doing. He said, "Oh, you better spend a couple of weeks mapping out your classes." I had to think for a bit. I said, "Fred, I don't use classes. Just structs and templated functions that adapt to what's passed in, design range selection." So if you, and that's one of the several things that lead to this mysterious plasticity in D. If you look at the Silver code for Silver use in production, you can still see bits of code I wrote in a hurry on Christmas Day, on holiday, as it were, with my wife. So so you can start off with a prototype and not have to throw it away. So just morph it towards something that becomes used in production, and then adapt to whatever needs come up. So I guess in conclusion, I'd say that I wouldn't suggest that most people use D. If you have to get a committee to approve it, there's a really good chance D is not for you. But if you're a creative company undertaking a different approach, the word disruptive has a slightly negative connotation, so I don't want to use that. But I suppose if you look at what WEC have done in storage, so they found out about D from a tweet by Kent Beck. No one knew D, so they based their entire company in it, and now they have the world's fastest storage system. So if you're a creative company undertaking a different approach, then I don't know where else you'll find language and language community that can offer what D brings. We're hiring, so we're looking for people to write, amongst other things, D, F# and TypeScript in London, Hong Kong, Singapore, probably about 15 people. So please do get in touch if it sounds like Symmetry could be sort of place where you'd be potentially interested in working. That's be done, but we can take questions.
All right, who's got a question? Walter.
Well, it's less of a question, more of a comment. I noticed you had a slide on John Boyd's
Yes.
OODA thing.
Yes.
I read his biography, and I'd never heard of the man before, and it is an amazing biography and an amazing life of that man. So I highly recommend it. John Boyd was a man in the Air Force who went his own way and kind of revolutionized the Air Force. And it's in a, his struggle against the bureaucracy and the way conventional things were done. I mean, he's really was really a man to admire. So
I fully agree.
Point that out.
I didn't want to go spend too much time on that, but here's this idea of a fighter pilot. If you're a fighter pilot, do you come up with a plan? Because it's a very dangerous thing, so you better have a plan and better think about change control, addressing the risk. Well, you don't do that. Observe, orient, decide, act. Observe, orient, decide, act in a loop. And it's simplifying dramatically, but he says that if you're engaged in a contest against an adversary or against nature, if you can be much more responsive, then you win.
All right, any other questions? Anyone? No one? Aha, here we go. Am I going to win? I'm going to win.
I wanted to ask about the kinds of projects you work on. Like for those of us who come outside the investment domain, what kind of programming challenges kind of fit in your domain?
What kind of challenges?
Yeah.
I'd split things up into three categories. The first one is that we're a company and an early stage company, and there's a lot to put in place for business processes. So you saw Robert Shattuck's talk. What happens if you've grown very quickly and you have people from the finance background? How do processes work? Well, it might be that sometimes you email spreadsheets to each other. It's not great. It's easy to do much better than that. And I actually asked Robert. I asked Robert. So Robert Shattuck worked on the back end for Symmetry integration language. And I said, Robert, suppose that I told you before you joined, I want you to work at Symmetry. You're going to be working on reporting with Excel, and you have to love it. What would you have told me? You're out of your mind, like really crazy. But turns out that actually many problems become quite interesting if you're able to explore them in a creative and thoughtful way. So the first category is really business process things. Steve Freihofer's, we've been learning from him about some ideas. Second category is kind of on the current investment side. So our approach to managing money is hybrid. So on the one extreme, you have the old school speculator who says, I think euro's going up. I'm going to buy €1 billion against cents or dollars. And maybe right, maybe not. That's a pure human way. And I slightly jokey, but it can work very well, right? The other extreme is you just have machines. And that's a legitimate approach. But our approach is more hybrid. So we want a division of labor between man and machine where, computers are very good at some things, but they're not so good at others. So have people, human capabilities working on what they're best at, have computers doing what they're best at, and sort of having a cyborg integrated approach. So building tools for portfolio managers, for risk takers, that's the second category. And the third one is more for research. And so that's things where we have insights about things that work, probably work. Like sometimes you know things work, but 10 years ago it would have been very difficult to have a computer be useful, at least. It would have been very expensive and a lot of work. So today, we've got an abundance of ideas, just we need to do more work on turning those into reality. So yeah, the kind of those three stages. And in each of those, there's various sets of different things.
Cool. Any more questions? Yes, one here.
There was a slide on unintended consequences of using D as an organization, and I found it really interesting. I can empathize with the thing mentioned. And do you think organization may inherit some features of D, and like plasticity? And would it be a happy unintended consequence that could be perhaps advertised more?
Yes, very much so. And I think we're in an age where people are always very goal-oriented. Sometimes, if you move towards, what's beautiful and true, then things happen that you never could have gotten had you tried to go for them in a kind of direct, calculated way. So I was speaking to someone earlier, and they didn't use version control. We used version control in a very primitive way. And we didn't really do code review, like 2016. And via having people collaborate with people from the community, or in some cases hiring them directly, that starts to lead to a slow shift in what we do, but also the way we approach things. But I mean, this is tacit knowledge, this is know-how. So it's very difficult for most people to read a book and actually have it radically change their behavior, particularly when you've got very little time. So that's maybe not a D-specific thing, but I think I think that they're subtler, softer, but maybe even more important things that where you're influenced by the way others do things. Herder, the German philosopher, said that writing about human languages, with languages, the most important thing isn't grammar. The most important thing is that they're language communities, that they're values that are associated with values and different ways of thinking associated with different communities. And I think that's true of computer languages too. So whether there's value for you in using D probably depends also upon what kind of person are you, what kind of firm are you, and what problems are you trying to solve. So for some things we're doing, I think the values of the D community may be as important as what you can do with the language itself. Did that answer your question, do you think?
Okay, oh, here's one.
You mentioned earlier that you use structs and not classes. Now, everyone here, you're right, comes from very diverse backgrounds and have different priorities. So from your background in investment, what did you observe that made you think classes were a bad fit for what you are working on? Like, what's your perspective on that?
So I guess, first of all, I should say that we do use classes now. We didn't at that moment. Yes, what a class is obviously good for, or not reasonable for GUIs and for ASTs. So for SIL, actually Dimitri changed them. They were structs before. Dimitri changed them to classes, and I pretended to give them a hard time. Oh no, you've ruined it. No, it's good. It's good. It's right choice. I guess the qualities of, so if you want to be able to adapt to change, you want your code to be readable and understandable, and you want to avoid bottlenecks so that you don't just have one person that understands it, that potentially there are a few different people that could help with adding a new feature. And I think that the qualities of coupling and, well, the quality of cohesion, really, it's quite nice, I find, to have, you know, if you've got various different kinds of financial instruments and you want to present value them, well, those things belong together. So I think the combination of just using structs and UFCS means that Scott Myers wrote about, you know, when you should write free functions and versus methods. But it just looks ugly. So lots of times people use O because it, you know, the UI they want the UI to be consistent. So with D, you can decouple that. Obviously, performance can be an aspect. So most of the things we need to do, I mean, we don't have big data, right? To me, big data is, you know, hundreds of petabytes. We have a lot of data that used to have in a spreadsheet, but really doesn't anymore. So that's today. And so storage prices are falling at 40% a year. Dataset sizes are increasing because people find a way to use it when it gets cheaper. And if you look at, you know, what's happening, Moore's law is not what it was, but memory bandwidth and latency. I mean, that's so then having control over memory layout, these things matter a bit now. In 3 to 5 years' time, I reckon they'll matter a lot more. But if you wait till you're sure it matters and you have to run to catch up, you know, it's much better to develop the capabilities to start, you know, if you want to write fast code, you have the ability as an organization to write it. And when we found that what Andrew said about C++ at Facebook, if you just write straight D, I mean, it's reasonably fast. As in, we have a market data server. So I wrote that in a real hurry. I imagine a frowning Andre peering over my shoulder. And that, you know, 0.3 seconds for 10 years 1-minute bars coming from Canada to London. You know, so we wrote a different way. It takes, I think, 2.5 minutes for 1 year 1-minute bars, maybe a bit faster now. So I think just having things naturally be reasonably fast and knowing that you can make things really fast if you need to, then, you know, that's pragmatic.
All right, any more? Yes, one more over here.
Hi, you spoke about the kind of cyborg approach at Symmetry. I was wondering what the information flow kind of bottlenecks might be with that. Like communicating to a computer with a keyboard, I guess, is one bottleneck, but like I wonder about other bottlenecks.
So there's a decision to be made here. Do you stay in the realm of great setting ideas, or do you talk about the practicalities? Because one thing is that it's much better in life sometimes to start with what you're already doing and working and doing more of it. So one element of our core strategy is fixed income arbitrage, fixed income relative value. Now, when I graduated, people said, "Oh, you have to be very, mathematical to do that," but not really. It's actually, I mean, you need to have a good feeling for numerical relationships. But in that strategy, we've always, it's not really possible to do it without a model. But what you need to be able to do is reason about the model, using the model as a kind of as a lens to view the world. So at the moment, traders who often would come from banks or would have been trained by people or work with people who have, what they're comfortable with is Bloomberg and a spreadsheet. So so maybe I made a mistake. We should be writing Visual Basic, or maybe we can think of the idea of there being many different different views onto the same reality. So people who want to use a spreadsheet can, but if you want to use Jupyter Notebook or command line, or have a GUI tool, Python script, they're all possible, and it's the same kind of, it's the same logic and the same view into the same data. More sophisticated things like, I don't know, virtual reality. I think they're interesting. I think it's for us right now. It's at the stage where, when it's possible, it'd be great to have someone just playing around with it. But I think it will be a while before that it's really that gives you a massive advantage over your competitors. Probably in time, I think there'll be things to do. I think we're still at a really, many of these technologies are at quite an early stage. I mean, even using Git, right? It wouldn't be something to boast about, but using version control, having tests, that's not the norm in the financial industry. There's a kind of every technological wave involves like a sort of S-curve. And in the beginning, it's quite flat. And looks like not much is changing. And we're sort of we're still quite early with many different changes, I think.
All right, I think we'll call it there on time with questions. So thank you again, ladies. Now, don't run away. Don't run away. Don't run away yet, because somebody has told me that it is, in fact, your birthday today. And I've also been told that there needs to be a song. So I'm thinking, like, we're all a multicultural crowd here. There's a million different versions of birthday songs that we sing, right? But, the actual happy birthday song is in the public domain now, so we can do this trouble-free. All right. So now here's the challenge, guys. Let's see if we can get a room full of programmers to sing in tune and in time. All right. Okay, so I'll do the tappy, tappy, tappy and start after I do 3, okay? So off we go. 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday to you. Amazing, you did it.
Thank you. It's also Andy Smith's birthday, so we should wish him a happy birthday too.
All right.
Also, Feng said happy birthday on the live stream. He said, "Good, well done, and happy birthday."
Thank you.
All right, so enjoy the rest of your day, mate. We've got, another 5 or so minutes that you can all have a quick break for before we need to be back here for the next talk. Enjoy.
My talk was on this. It was surprisingly good.
Yes, I don't know how you people managed it. Really, I don't.
Well, because I was in the front and I'm on.
All right, yeah, okay. So, thank you for saving the day and knowing what Mars is.
Now that we were saying too late, shouldn't he offer drinks to everyone?
I think it goes the other way around, where you meant to buy the birthday boy drinks, but who's next? Who did we put next? We did put Adela next. Okay.
If I need like a couple of minutes just for a quick smoke. I'll be like,
yeah, sure. I mean, we're setting up now anyway, so off you go. Where'd Lace go? I need his wire. Can I get his wire? Thank you.
Oh, sorry, yes.
Yep, by all means. Cheers. All right, you're probably the only person here I don't need to tell how to set up this stuff, so.
Probably not.
You got the HDMI in good. This monitor should be on as well. I don't know why it's off. But the dude was just heading out for a ciggy. He'll be back. But yeah, those two screens replicate what's up there.
Okay.
Standard HDMI, so you can duplicate or extend your displays, whatever. You don't need that explained.
This is the slowest post ever. Why you still staring? This can't be right. Come on, computer.
Wow, I've never seen that line on it before. What was that?
That was the boot.
Or was that Grub or something?
That was system deboot
Oh, okay.
with lots of entries because I'm trying to figure out.
Just said it was scanning and repairing a drive there.
It does that all the time. I don't know what's going on. Picture of me from 100 billion years ago.
Yeah. Actually, one other thing that I'm trying to do with everyone is make sure I pronounce their names correctly, and I'm pretty sure it's just Attila Nevis. Okay, good. I was certain I'd been mangling your name for years, but
No, so the thing is, I pronounce my name in English when I'm speaking English.
okay, fair enough. Attila Nevis, got it. Yeah. Other than that, we're starting in about 4 minutes.
I don't have an actual viewer. Shit. Yeah.
Adobe Reader has a full screen viewer.
What does Chrome?
Well, Chrome should be able to do that as well, right?
But with pages?
Okay. Yeah, you might need to go into a viewer program then. Fair enough.
That's installed.
All right. Well, you got 4 minutes.
So how do things work with the lightning talks? Do you need to submit it somewhere?
Best to talk to Mike about that right now, please. Thank you.
So he was a maniac for eliminating weight on
Screen's coming through in the feed fine?
Yeah,
Excellent.
downloading.
Yeah, he's downloading an actual viewer so that he can get a full screen of his slide. It's in PDF format, but he's only got Google Chrome there for reading PDFs, so he's got to fix it up properly. All right, man, just let me know when you're set up and I'll yell out for people have a minute.
I want presentation about. Does it want to have a thingamajig? Well, I have to keep it on the back of
If you need a clicker, you got that. USB here. It should, if PDF, should be able to read the forward and back on that.
Okay.
And when I was trying it out, the weird thing was that down goes forward, so whatever.
Okay.
It's a bit unco, but it works. Yeah, the feed's coming through. It's fine. I just checked with him.
Oh, okay. So I don't need to do anything.
You don't need to do anything now. When you're ready to go, you switch the screen. All right, I'll yell out. All right, we're live in 1 minute, people. Please come back inside. Okay, welcome back, everybody. Everybody? Everybody. Yeah, I'm with it. I'm cool. All right, please, you take your seats over there. All right, good enough. Good to go. Oh, we were going to play that little D game, weren't we? Hold on. Let me bring up my little trivia. You got the prize? Yes, and Mike's a prize for me over here. Thank you, Mike. All right, let's find a good question that people can answer. All right, here's a bit of trivia that Walter provided me. What was the model for D's nested functions? Where did he get it from? Nicholas put his hand up first. Yes, correct. So he said Pascal for those who can't hear.
Woohoo! And you didn't see it, but I put my hand up as well.
Yeah, you should be in the crowd. Hey. All right, so what do we got here? We got a Dr. Strangelove reference in the title. I like that. Subsequently, there's a Kubrick exhibition over at the Design Museum at the moment. I looked at it on Tuesday. It's pretty good. Completely unrelated. Attila Neves is going to talk to us about frictionless D adoption. So give him a round of applause.
Thank you. So basically, the C processor sucks, but it's also awesome. And, well, we'll get to it, I guess. All right. If you remember just one thing from this talk is that programming is about people. I know that we want it to be about the tech, but it's not. Trust me, I want it to be about the tech too, but it isn't. It's always about the meat bags. If you're not thinking about the meat bags, you're going to fail. So if you take one thing from this talk, that would be it. I'm done. No? Okay. Story time. So John Montague was the 4th Earl of Sandwich, and apparently, according to legend, he liked to play cards. He also enjoyed having a little snack while he was playing those cards. And he wanted to keep one hand free for the cards, one hand for the snacks. So he asked his valet to bring him some meat in between 2 pieces of bread, and voila, sandwich. The other guys that were there said, I want what sandwich had. The name caught on, and this is why there's a picture of delicious BLT up there. Why did I talk about that? Because it's a story, okay? So humans, for reasons, respond really well to stories, and people sensitive to storytelling. Research has shown that if you use a story to relay facts, people learn a lot faster, and the retention of the facts is a lot higher. In fact, if you put electrodes in somebody's brain, that's an actual picture, the brain fires up. It's not just one region of the brain that fires up. If you show them bullet points, you get one region of the brain firing up. If you tell them a story, the whole brain lights up, and things are better that way. So you're now unlikely to forget the story about how the sandwich was named, whether or not that story is even true, because there's no way to know. But you're not going to forget it. On the other hand, nobody's going to be talking about the slide at all, because it's boring. Boo. So that's why I told you a story, because stories are important, because they're important to people. And like I said, programming is about people. So if we don't account for the people we're working with, we're not going to be successful. So the whole point here, I think, is that I think everybody in this room wants the adoption to grow. And if we keep forgetting this fundamental fact, we're not going to succeed in achieving that goal. So again, programming is all about the meat bags. Drats. Right, so to contextualize the story, this is your basically who I am slide. If you don't get why it says why instead of who and who that blue guy is, then you haven't watched Avengers Infinity War, and all I can say is I feel for you. It's amazing, go watch it. So I've been a D user since 2013. Actually, this conference was a big part of that. I was watching the videos online, thought it was really interesting, downloaded the compiler, started trying the language myself, and very quickly also read the T programming language in one sunny afternoon from cover to cover. Very quickly, it displayed C++ as my language of choice, my favorite language. So I started getting really into the D community and ecosystem and all that. The next year, I ended up at DConf 2014 at the Facebook headquarters as a speaker. Started meeting members of the community. Really started, get into the swing of things. So I wanted to use D round about that time. Unfortunately for me, that was also the year in which my previous project at work had ended because we had achieved everything we set out to do. And so they had to move people to a new project. So they put me with a bunch of programmers I'd never worked with before. They were all C programmers, and we were about to take ownership of a code base that was written by a completely different team in a different continent. And they just handed it over to us, and now it was ours, which is every programmer's dream, right? Living the dream, taking ownership for somebody else's crappy code in C. So that was great. And the thing is, there were no tests, right? I mean, the previous team didn't write any. Well, they wrote a few, but there were hardly any. They didn't even compile anymore because they hadn't been running so long. And I told the team at the time, remember, they didn't really know me. We can't change the code until we cover it with tests, because or else we'll break it. I mean, who knows what we're doing there. I really recommend this book, which is instrumental in some of the techniques I ended up using to test the code we had, because it wasn't made for testing. They didn't have the tests in. The culture at the time when I was working at Cisco was really to do end-to-end tests on actual hardware. And the hardware obviously isn't a PC, so that makes things more complicated. They usually actually serial lines to talk to the boxes and type commands and that kind of thing. That was the environment I was in. So reading this book's really good. I recommend it if you have to work with legacy code. It's mostly focused on OOP techniques, but it doesn't, so Java, C++. But it does mention some C code techniques you can use as well. I didn't manage to get anybody else in the team to read this, but what are you going to do? The code base is in C. That doesn't mean I have to write tests in C. In fact, I don't think that's ever a good idea. I mean, there are reasons to pick C, although not that many, I would say. Basically, if you have a compiler for anything else, use that instead. However, you don't need to write tests in C. I mean, you're just making life hard for yourself for no reason at all. And so I had to decide what language to use. Now, I wanted to use D, but I ended up using C++ because it was easier. Did I like that choice? I did not, but I had to make it anyway. Now, why? Well, first of all, again, new team, and they didn't even do tests. This is a culture where they did manual tests and thought that was a good thing. When we talked to them about automation, they thought that was a bad thing. I don't know why, to this day, but it was. So there's a culture problem already. So I'm already fighting to even get the tests in to begin with. I counted the number of meetings we had to discuss unit tests. It was 8. I counted them because it was so frustrating having the same conversation over and over again and tried to convince people that unit testing was a good idea. At one point, somebody said, but you want us to do more work? And I went, no, I want to do less work. I'm a programmer, I'm lazy. That's definitely not what I want. I want to not break the code and not be debugging for days in a row. So if you're arguing, you're losing when it comes to persuasion. So don't argue. And basically, I was already arguing about tests. So this is already a situation that's hard enough to begin with, okay? I'm already trying to convince them. They don't know me. They've never worked with me. They don't trust my judgment or anything like that. Or I'm having to prove myself. So in a way, my career is on the line. So I have to try to make choices for this team that would make sense. And again, if you're arguing, you're losing. So also change, right? People hate change, it turns out. They really, really do not enjoy it. Well, most people. There are weirdos. But for most people, change isn't good. And if you're wondering if the slide title is supposed to be sung to a song, it is. Most people have this naive model of change, in which these diagrams are from Peopleware, by the way, which is also a great book that I recommend. In fact, anybody managing a software team should have to read this book before going forward. It's basically where I learned that it's all about the people. In any case, most people think you have an old status quo, and then a better idea comes along, and everybody is enlightened immediately and goes, hello, new status quo. Nope, that's not what happens at all. What happens is usually there's a foreign element, in this case, me, in that team, introducing an idea, then chaos, and then there's a bit of time so that they can get used to that, and then they practice, and then they get better at it, and then the new status quo happen. If you want to know more about it, like I said, just consult the book. And the change doesn't really happen until people feel safe. If they don't feel safe, they go straight back from chaos back to the old status quo. So you need to take this into account as well as the evangelists out there. Maybe the best way isn't to jump straight in. Maybe something like Better See is a way to get them in the language. It has to be piecemeal. It has to be easy. They have to feel comfortable. If they don't, it's not going to work. People don't like change, and I was introducing change as it was. There's also this phenomenon known from psychology called loss aversion. For probably evolutionary reasons, people prefer. Well, we're really averse to losing anything, and apparently, some research shows and indicates that loss is about twice as powerful as gain. So it only evens out to people when it's about twice as much. So loss bad, gain good. Some of the psychology experiments, basically, if you give somebody money and then take it away, they feel that much more strongly than missing out on getting the money to begin with. So we don't want to trigger that aversion. We don't want them to feel like they're losing something by going down your path of change, whatever it may be. In my case, again, trying to cover this code base with tests. And automated testing was chaotic enough for them. Getting them to adopt D, that's a lot harder. So, I had to be able to sell that. But you can tell me, you can write the test in D, right? What's the problem? It's called the C code. No big deal. Sure, okay. So if you go to dlang.org right now, and, I can't remember exactly what it's called, but C interrupt, whatever it is, that's the example they have, shrinker. First of all, nobody's going to do this because it's already done for you in standard library. The declaration is already there. Secondly, if those are your problems, good for you. But normally, you're not trying to call a function that takes two const shards and returns an int. It's usually much, much more involved than that. In reality, it probably looks like this function I called weird API here, in which you have pointers to structs instead, and then some integer, and I called it weird API because naming is hard. Now, the thing about this is that foo will be in foo.h, bar will be in bar.h. And then if you go look at those structs, they have substructs within them that are in different headers, which if you go look into those, other structs, other headers, and this goes on and on and on. And the code base I was trying to cover with tests, that would recurse about 20 times. Completely different headers. So that's what the real code that people are trying to call looks like. It's a lot harder than that. And there's another problem as well, because you see int flags there. What'd you pass to it? 42, 33? Nope. You need the preprocessor, because that's how the API is designed to be used. Okay. So what you can do here, of course, is try to emulate the preprocessor using CTFE, for instance. That can work, but it's also manual. You need to figure out. And sometimes it won't quite work because the semantics is slightly different, maybe. Here be dragons. And also, so the way API is meant to be called is like this, with the preprocessor actually using the flags there. You're not assembling it manually. As you can see, weird API returns int, but in the call, nobody's checking for the error code because it's a C API. Let's face it, every return value is an error code, and normal programmers don't usually check. And so, what do we say to the god of error checking? Not today. Anyway, so that's what real APIs look like, and that's a problem. And then you get things like this. If you have nested structs. Sometimes people write macros like this one to facilitate getting a member of a struct, because obviously writing code is more important than reading it, even though you do the latter a lot more. You can tell me who would do such a thing? Psychopaths that write code that I didn't have to manage. That's who. But they do this. And it turns out that this shows up in the code all over the place. I kept trying to jump definition. That function didn't exist because it was a macro. Can these things show up in APIs? They can. It's probably rare, but these are actual problems. And these are problems that I had in that code base. These aren't even theoretical problems. These are things that actually happened. So this complicates matters a lot. So what we can do, I could manually write all the declarations and recurse myself into headers and look at them and then do this and do that. and look at if-defs, because that's the thing. The struct declarations can use a preprocessor too. Which version do you use? How are you going to compile this? Are you going to do version blocks in D? Are you going to do static ifs? You can, but that is a lot of work. I reckon that it would be weeks and months of manual wrapping just before we managed to write the tests. Okay? I tried D-step. It didn't work. I don't remember what happened. I just remember it didn't work. And I at one point was trying warped the preprocessor that Walter wrote, because I was trying to see if I could at least just run the preprocessor first and somehow get the declarations from out of that so I wouldn't have to recurse into the headers. Warp didn't work on it either. Sorry, Walter, no, I don't have a bug report because I can't remember what happened and I don't have access to the code anymore. And Calypso's a non-starter. I mean, yes, there's Calypso, but it's a fork of LDC that does this weird thing in which you can use C++ and D together. But, again, they don't even know D, okay? If I'm going to convince them to use a different language, and they go on the internet and look up how to use DMD, and I tell them, no, actually, no, it's this other thing. It's a fork of another compiler. That doesn't look good, okay? The loss of version thing will trigger immediately. They'll just go like, nope, don't want to. It's a non-starter. It's not a viable option. And so because of all of that, I picked C++. Because, back. That is the elephant in the room. Okay? And C++, this is all the work you need to do. The externcy might not even be needed if somebody wrote the header properly, but in this case they didn't, so it was. But that's all you need to do. There is no conversation happening anymore. You do this, it's done. All of the structs are now usable. All of the API and all of the preprocessor macros. And they work exactly the same way. There is no loss. It is as smooth as can be. Okay? No argument here. So I did that. Also, I mean, these are C programmers. They didn't even know C++. Okay? So that is also a bit convincing. But they could pretend to write C, sprinkle in some niceties maybe, like using std vector for the test, and really not have to be any the wiser. They can just write the code they already know, and it will work, and it'll compile, and it will link, and it'll do what they think. So this annoyed me because I wanted to use D, but I couldn't. Okay? For me, this was the advantage that C++ had. And I wanted this for D. I wanted it for somebody like me who wanted to use D to not have a reason not to. And that's the advantage C++ has. I think its rise to power, from a historic perspective, has everything to do with that. I don't think we'd be here right now if C++ hadn't done what it did, because Walter wouldn't have implemented the C++ compiler and wouldn't have invented D. And the only reason anybody's still talking about C++ is because it made the transition completely and utterly zero cost. Oh, you have a C code base? No problem. Just create a new file with the CPP extension. Everything will work. You can use your old APIs. Nothing changes. In practice, it's a superset of C. Yes, I know it's not, and I've run into edge cases where it's not. But in practice, it is. We can just pretend it is, and it's a first approximation. That's basically the case. Incremental adoption, no cost. There literally is no cost adoption. If there's no loss of version. You can't be averse to something that doesn't even exist. You can't lose by arguing if you're not even arguing in the first place. If you're arguing you're losing, no argument. And I believe to this day that C++'s killer feature is hash include. It's one thing that that differentiates it from anything else. It is the one thing that caused me to pick C++ for this project instead of D, because there is no work involved. So my conclusion, of course, is to shamelessly copy what C++ did. That's how it rose to world domination. That's how it conquered so many people and swallowed up whole projects. I mean, even GCC is in C++ these days. So let's do that. So what do we want it to look like? This. This is a hybrid Frankenstein monster of my creation. If you don't look carefully, it just looks like I wrote C code, but I didn't, right? Because you can see a scope exit there and a const without an auto, so it's not even C++ either. So that's D code, except it's not, because there's hash includes, which isn't valid D. So I want this to happen. I want to be able to write this code, and I want it to compile, link, and run and do what it's supposed to. Incidentally, those AF, SP, and NNPub values there are macros, because that's how you're supposed to use the API. It always happens in any non-trivial C API. You always need a preprocessor somehow. It might just be constants, but it might be something more involved. So this is what we want to do. I want to replicate the C++ experience of interfacing to C. I want it to be as painless as it is when you write C++ and are interfacing to C. I want everything to just work and not have to think about it. The other thing about this as well is that I don't want to see any D declarations from the headers either, because why would you? That's for the compiler to know. And if you want to know what the functions you're calling, go read the header. I mean, C code isn't that much different anyway. So just go to the origin of the code you're calling, go look at the declaration, and that's fine. So how do we make this work? Well, like D-step, DPP uses libclang. I call it DPP kind of for marketing reasons, I hope. I read it either as D preprocessor or D++, take a pick. So first we use libclang, which is a C API on top of the Clang front end. And that way we can call into Clang's parsing engine via D, so using the C API. Then we take the AC that we get from the headers and we translate those into D syntax. We do have to deal with some impedance mismatches here, though, because, for instance, C, you can have multiple declarations. You can have as many as you want, as long as there's only one definition, but not in D. So we need to fix that. But the thing is that when you're including a header, you don't get things in the nice order, as it were. So you need to go find out which one of those you want to actually use. For instance, for a struct, you can do struct foo, semicolon, several times, and then have a definition somewhere else. So we need to find that one. Now, libclang does have a concept of what's canonical. You would expect naively that they would pick the definition as the canonical one, but they don't. So I have to do some filtering basically after it's being parsed to actually get the information I need, because I can't repeat myself because the decompiler won't let me. There are other little issues as well. And then the idea is to take those headers, expand the translations in place, just as they are there. Basically what the preprocessor does in C and C++. And I originally did this per header file. That didn't work once I found a bug, because there's a big C project, I think it was Postgres even, in which you're required to include a certain header before you can include any of their other headers. So their headers aren't self-sufficient. If you don't put the declarations here, the other ones don't work. So I can't do that anymore. So what I do is I take all of the headers, all of the includes I see in a DPP file, copy them somewhere else in the file system, and then parse that alone by itself as C or C++. The translations are meant to be checked in, which means after you convert C codes to D, I don't actually want to look at the file. To me, this is just part of the build system. Okay, you generate some D code as part of doing your job, but you don't actually look at it. That's not what you're working with. So they're not. It's a different philosophy from DSEP in the sense that instead of translating and then importing that module, you don't. Right? You don't look at it. You just, again, replicating the experience. I want it to work just as easy as. And the other big difference, of course, is macros. What do we do with those? Now, by the time you've used libclang, it's a compiler. Okay. The first step in compiling C or C++ is a preprocessor, but by the time you've parsed, the preprocessor is gone. It doesn't exist anymore. All of the macro declarations are gone. However, probably because somebody else is doing something similar to what I'm doing here, libclang is an option when you parse a source file that it remembers where the macros were, even though they're gone. So you can query it for the macros that were in those headers. And then what I do is redeclare those macros in place. So if I have defined foo something, I go find out where foo was, go open that file, read it from this position to that position, which is where the definition is, and paste it in line. Exact same definition. Because instead of fighting the preprocessor, I figured just use it. I could use warp to something like that, but instead just call the C preprocessor. So the idea is expand all the declarations in line, take all the macros and paste them in here, and then run the C preprocessor in the result. That means your code, the user code, the code that the user sees after the includes, can then use any macros that were defined in those headers. And then the C preprocessor takes over, expands those for you, and everything just works the same way it would have done otherwise. Is it hacky? Yes, but that's how we do it. If you can't beat them, join. And then, of course, at the end of this process, you have actual valid D code, right? Because this here isn't. This isn't valid D yet, but it becomes valid D after this process of expanding it in line. So what the compiler will see afterwards is those includes are gone, and then you have a bunch of definitions there. Yes, Walter.
So you're running the preprocessor also on the decode,
Yep.
but then you've got a, it expands to C code.
We'll get to that.
Okay.
So the good thing about this is, and then we call it decompiling the resulting code. The good thing about this is I'm wrapping the compiler, right? It's a layer on top of it. It's not replacing the compiler. It's not a fork. Those things are scary. This is, chocolate bunnies and flowers, because there's nothing to be scared about. The compiler's just doing its thing. I'm just pre-processing beforehand. Again, I'm shamelessly copying for C++. The first implementation was it pre-processed what became C++ into C and then compiled that. Yeah, let's just do the thing. So that's how it works. But yes, there's problems with that. I'm not entirely sure how to fix it either. So how do I call libclang from D? Fortunately for me, Jacob wrote D step and already had the bindings. So there's libclang declarations in D syntax. Because obviously I have a chicken and egg problem here. I can't use this project to, translate. What I did do, though, is I added safe no GC pure no throw to every single one of those declarations. Now, is it safe? Yeah, probably. I trust those guys. Is it pure? Look, if a pure tree falls and D doesn't see it, it's pure. It's fine. It's obviously no throw because it's C API anyway. And I also added into all of the parameters. The reason I did all of this is because I hate writing code that's not safe, that's not pure, and that doesn't use const. Okay, that deeply disturbs me. So I did this. I basically trust the libclang implementation, and I do make one exception for callbacks because the way they do it is basically they kind of implement the visitor pattern in the sense that you give them a function that they run on the ASC nodes. And I can't guarantee that function is going to be safe or pure or whatever. And also I can't limit what users can do calling libclang, so I don't do it there, which is the only place I can't. But the good thing is I can write safe code, pure, and also use const values everywhere, and things work. I mean, I haven't corrupted memory yet that I know of, so it probably works. And then I wrote OOP-like wrapper for the C functions, right? Because they're annoying to use, so we just declare a struct, some member functions called the C API. There's a few other things that I did as well. I put all the enums into their own namespace, so they're easier to use. Sometimes they don't look exactly the same as what's in the header, so I have to go back and forth, but I still think it's a lot nicer to use it that way. So that's how we call libclang first, and then we just tell it to parse because that's what it does. So in the implementation, what we do is, so libclang in its parlance, the AST is made of nodes. They're called cursors, and cursors can have types or not, depending on what kind of cursor. For instance, a namespace cursor doesn't have a type. That doesn't make any sense, but a function does, a struct does, etc. And so we go through, so at the head of the AST is a cursor that's of type translation unit, and then it has children, so also cursors, and then you loop through those. And each one in turn, you translate differently. So I had a big switch case in which you're just switching the cursor kind. They can't use the word type here because type obviously means something else in the language. So each cursor it can be a different kind, a struct declaration, a function declaration, etc. And so, I mean, this will look familiar to a lot of people because this is not, rocket science. So I'm not reinventing the wheel here. Funnily enough, I took this version from where I hard coded the name of the struct. So this worked as long as your struct is called foo. It's like Henry Ford's car, right? You can have any color as long as it's black. Same here, except foo. And then, the struct declaration stuff, it makes sense. You take the struct, you declare the name after, of course, I fixed this. You loop over each field, which is the child cursors within it, and then translate that. And this is in a top-level translation function that just dispatches to whatever it needs to do. However, I hate this pattern. As you can imagine, this code could grow and get several pages long. Don't like that. So I actually think it's really good, and this is the reason why I'm showing it. I think every single time you see this pattern and you have more than just one line per case, I think you should do this instead, right? What I did there is I have a bunch of translation functions, each for a different kind of cursor, and I put them in an associative array, and then you just dispatch based on that. The good thing about this is you never have to write default, and you never have to worry about either, because if it's not there, you get a range error. So I use this technique in any language you can do this easily, including Python, D, etc. Because again, you never have to deal with the default case. It's handled for you by the machinery of the associative array. And also, this is a lot nicer, smaller. The dispatch becomes this, and then you can go into each individual function to see what they do with the cursors that they're supposed to handle. And then the technique here is cursors have children, and then they can have children, and they can have children. So you keep recursing AST until you translate everything. All right, I forgot. I think I forgot a slide here. Anyway, so what you do is you recurse on them, and the cool thing about this is that I wrote some code to translate arrays. Okay. Now the thing about static arrays is the order of the numbers in D and C are the other way around. And I wrote a function to translate 1D array sorts because that's easier. Then I wrote some tests for 2D and 3D arrays going, haha, I'll get you now. The test passed. What? Turns out by using recursion, I didn't have to care. It just fell out naturally. And that's the other good thing about TDD is I didn't have to write that code either, because if I approached it assuming that I needed to deal it separately, the code would still be there handling it separately, and being complicated for no reason. Write the test, it passed. Wait, that's weird. Verified it actually, works as intended, and then I didn't have to. So that was cool. So you just keep recursing that. This top level translation function keeps dispatching to itself at the end of the day. So you go into fields, and the field might be a struct, so it goes back over here, and then everything gets handled for you, and there's no special machinery to really have to deal with that. I also want to say something about testing, because I think it's really important to basically write your own test framework for each project you work on. The test should be easy to write and to read, and you shouldn't get lost in the machinery of verifying things, okay? So this is actual test code from the project. I don't think I need to explain what it does, right? It's more or less obvious that I'm taking C code, right? Some D code, and that stuff should compile. Now, the other thing I think is important about this test is there's I think a mistake a lot of people do when they're writing things that translate code into other kinds of code, which is to write tests that assert that the output looks a certain way, right? So if I have the C code, this D code must look like this. I think that's a mistake, because the compiler doesn't care how you format your code. And that's a brittle test. You change anything about the test or the implementation, and suddenly you have 50 tests breaking, and for no reason. This is the worst kind of test possible, a test that cries wolf. It's broken, but the code hasn't actually broken anything. So I think it's important to show that I believe this is a much better kind of testing. What I'm doing here is, instead of asserting that the output looks a certain way, I'm actually trying to compile D code that has included that header, and then doing static asserts on properties that should be true regardless of how the formatting happened. And therefore, this can never break, right? It can't. So yeah, I think this is really cool that obviously I had to write the function should compile first, but then when you do, you keep using this over and over again. And now your tests are more compact. It's readable. You don't really have to explain to people. I'm also using these quoted strings here for code. I mean, they're only meant for D code, and I'm also using it for C and C++, but the syntax is close enough that Emacs doesn't care, and it looks pretty. I mean, just try it. It's a common refrain with me. Just hack around. Does it work? Yay. Don't think about it anymore. The other thing that's good about this is also you do need to be able to debug when a test fails. Because if this fails, all you're going to get is saying, yeah, I couldn't compile it. So I made an effort to, this is what happens if you change this 16 size of here to 15. So you get this instead. You said you can't execute DMD in this code. The error was that static assert wrong size of foo, and then it prints out the D code that actually translated with line numbers, so you can actually look. And you can see that the line numbers start at 53 because there's a preamble. I don't want to look at that. I mean, that's always the same stuff, and it's just going to take up space on my screen. So I think this is important as well to show how my approach, at least to testing and trying to make things easier for myself. I hope it catches on. Yeah, right. So that's what I was talking about for recursion. I did have that slide. It just was in the wrong place. So you recurse and keep dispatching test-driven development for the win. There's another time, actually, which TDD saved me. I didn't have to write the code. I learned that you can return void. You can do return function call, and that function call returns void. I didn't know that until I wrote a test assuming that would fail, and the test passed. I went, oh. I don't have to do anything after all. Again, if I hadn't done that, I would have a static if there somewhere, and for no reason. It's a lot simpler. So, things that I learned about C even after 25 years of writing C. Once you start looking at real projects that people actually wrote code in, seriously. So apparently this is valid C code, okay? You can have a function pointer called y, and also a struct y, even in the same struct declaration. This is fine. Now, of course, in C, what happens is you have to say struct y unless you have a type def. And then you say to me, what about C++? Well, it turns out C++ doesn't need to use struct whatever, but you can. So if you include this header in C++, you can disambiguate which one you mean by one saying struct and the other not. So I had to deal with this by renaming things. But I didn't know I had to deal with this until bug report, GitHub. Also, I learned that macros can have the same name as a function. And in particular case I was looking at is because so they could inline it. I guess before compilers did it, I don't know how old this code was, but the definition of the function just had the macro inside curly braces. They return this, right? So that can happen. Now, the way C does with it, because think about it, if the macro is the same name as the function, wouldn't the function get replaced in the header? Not if you put parentheses around it, it doesn't. That prevents macro expansion. Who knew? But people write real code like this. I mean, if you actually try to use real libraries in the wild, this happens. So you have to deal with it. And you can't do the same thing in D, right? That declaration in D isn't valid. DMD will not accept that whatsoever. So I can't put parentheses around things. I have to rename them again. The good thing is a pragma mangle is a thing. So if I rename any functions, I can just tell the compiler how to mangle it. It will link fine. So that's fun. Macros as well, super fun. So it turns out there's some flies in the ointment when you try to use macros as they are, because as Walter pointed out, they're C code, they're not D code. And in fact, they're not code at all, they're text. So if you have, for instance, pointers, right? We don't have arrow syntax in D, but that's easy to fix. You just, any mention of an arrow anywhere, you replace it with a dot, you're done. Size of X is now X dot size of, again, you replace it. However, what if it's not exactly size of X? What if there's a space? What if it's in the middle of something? I had to use regular expressions. I'm not proud of it, but what are you going to do? Then I found out there's a lot of C-casting macros, like void star. Somebody actually defined their own null. Again, possibly before standardization, who knows? But they were casting 0 to void star in such a manner, so I had to deal with that too. So, okay, how do we do this? You look at the macros, you look to see if there's anything in parentheses that looks like a type. Void, void star, int, that kind of thing. What happens? Lathe files another bug because he finds something like oops4. A user-defined type in the cast. Okay, so now I have to remember all the types I've looked at before and see if any of them show up in parentheses somewhere. Okay, what about if it's a macro parameter? I don't even know if I handled that one. So this is hard, and these macros happen in the wild, and the goal is to be able to use them. I'm not entirely sure how to solve this problem because, like I said, I had an idea to take whatever the text of the macro is and then write that to a file and put libclang on it and parse it. The problem is it doesn't have to be valid code. Some of the macros are only valid code in context, okay? So you have this one here with the struct initialization. That's not always valid code. It depends on how you use it. In this case, to initialize a struct with other macro inside of it. But I can't just look at patterns like this. At least I don't know how to write a program that looks at patterns like this and figures out what the macro is supposed to do. As a human, I can tell, especially because of the name. But I don't know how to write a computer program that can do that for me. For instance, the braces might be a function declaration. I've seen macros like that, just to write code for you. Which one should I do? I don't know. And also, if I have a macro with a bunch of parameters, what are those parameters? Are they numbers, strings, quoted strings? I don't know. As a human, I can probably guess and look at code examples, but the computer can't. Or again, I don't know how to do that. So this is a hard problem, and I'm not entirely sure it's fixable. And basically, I've just learned to live with some of the macros not being usable. For the most part, it seems to work, so I'm not too worried about it, but it is an issue. So does it work? Question here.
So what about like doing the the correction of those macros after the macro expansion, because then you know a little more about the context in which they appear.
That was actually John's idea. Basically, look, so well, we can cheat, right? If the macros are never used, it doesn't matter. And if they are used, you can see how the user used them and then do that. That is an idea I'm going to explore. I just haven't gotten around to it yet. So this code here, does it work? I copied this. This is one of the tests. This works today, right now. Okay. So you can use nano message and just include that header and call into it. What else works? As an example, as soon as I get back to the slide. Curl. So I look at libcurl. That was one of the first ones that I was proud to actually be able to use properly. And I wanted to make sure that I wasn't just, translating gibberish. So I went on the internet and I looked at a curl example in C. Copied the file wholesale, pasted it, and then did 3 changes. I put 2 strings on the string literals because they're not the same as in D, right? I changed fprintf to stderr, right, Ellen? And I put stdconf text in there somewhere. Those are the only 3 things I did to the C code. It runs exactly the same. Include python.h. That works. Macros and everything. Writing a replacement for PyD using this. And the good thing about this is it will just work. For instance, when Python went from 3.6 to 3.7, PyD started crashing. And the reason for that is they added a member to one of the structs in the header. And of course, you have to update the daemon bindings by hand. This would not happen here. It would just be part of the build system. Header change, go, boom. Oh, okay. I was wondering what you're doing there. So, it would catch this kind of errors, we had it crashing first. Then I had to figure out why. Then, look, I had to actually look at the change logs for Python, basically, to see what happened and why it was crashing, which is not what you want to do. I managed to come to the C standard library by just including stdio and using printf. That worked. malloc as well, free. I didn't try anything after that, basically, because, it works, ship it. So, except for bugs, yeah, it works. I mean, right now, you can probably include whatever C library you want to call and use it in D. I mean, Robert mentioned that the other day. He just used DPP to translate the header files and he was done. It took a little while, but it works. The interesting thing about this is, first of all, of course, this is, I think, monumental, the fact that you can just call it to C easily as this now. If I had this at the time, I might have tried to convince the team to write the test in D. And the other thing I realized the other day that I still need to write a blog post about is, if you combine this with autorap, the easiest way for you to call C from Python is D. Translate the headers into D, reflect, generate, off to the races. Build system detail at that point. So I think this is huge. Yeah, this is actual code from that project I was mentioning. You just include Python. I thought it was really cool. I could determine if it was Python 2 or not by using D on a C struct. Does this type exist? Oh, Python 3 then. And then you can use this in static ifs and stuff like that, which is a lot nicer than any other way you could have thought of, right? And I didn't show the rest of the code, but there's macros in there as well. I basically demacrify things by, in this file, using either a template mixin or some kind of thing like that, and then expand the macro in there. So then you can mix in that template because it was supposed to be code generation. Some function-like macros, I basically turned them into a function by writing the function and then return expand macro. So I think it's pretty cool. And it will just work. And if you need to use different compiler flags, maybe you have if-defs in those headers. Maybe there are options to using Python that you want to reflect in the library. You can't do that with normal bindings unless somebody writes version statements with static if and keeps those in check. Here, it just works. Just pass -d whatever to DPP and it'll work. So the holy grail for me would be actually to supplant C++, but being able to do that. Okay? Just include a header from the standard library and then use the C++ standard library. Or any other C++ library out there. It has to be this easy, because or else people aren't going to use it. Nobody's going to consider moving away from C++ unless it is this easy. So I think that this has to happen. And, never mind the standard library. What about Qt? What about Eigen? I have a friend of mine at CERN. He said, these sounds really interesting, but I need to call into Eigen. I went, well, yeah, you're out of luck. There's no other way you can do it. Heavily templated library. No other language can do it either. So it has to be this easy, but I'm trying to get there. But it turns out, who knew, C++ is a teensy-weensy more complicated than C. Somebody should have told me that. Also, libclang is not everything it's cracked up to be, it turns out. For C, it's fine. It's got all the functionality there. But for C++, there are a lot of things that are missing because nobody's needed them except me, I guess. So their C++ API is obviously going to be able to do everything because it is a C++ compiler, but whether or not that's available in the C API is a different story altogether. So for instance, there's no way to query for const extra. It'll tell you it's a const value, but it won't tell you it's a constant expression at all. No way in the API. So what do? I cheat. I look at the tokens, and if const extra is in there, enum. What are you going to do? It's ugly, but it works. There's no way to get a struct's template parameter, so I'm bending over backwards right now to get things to work, especially with template specializations. It's an absolute nightmare. Then you have to have an algorithm to output either a destruct or a class because C++ doesn't have distinction. So now you need to look at how this type is supposed to be used. I haven't done this yet, but I'm pretty sure that it's enough to use class if and only if the type has virtual functions, because I can't see how it wouldn't be a class otherwise. There might be some weird hybrid types out there. Let's just pretend they don't exist. They probably don't. I think that'll work. But certain things can't be translated at all. For instance, its reference from the standard library, from type traits. I was trying to avoid type traits, but it turns out as soon as you include the C++ header, you're including type traits, whether you want to or not. And I can't write this in D because there is no such thing as a reference type. This is a template in C++ that's specialized for references. I can't write that. I can't. There are no reference types. And so if I can't write that, I immediately realize, hang on, this is probably going to be used in Sphinx somewhere. I can't write that either. I don't know how to fix this. I'm going to have to see. But however, I think there's a silver lining in the fact that D is the only language that has any hope of translating any of that. Because I looked on Google today, template specialization languages, and since it didn't show up on page 1 of Google, it doesn't exist, as we all know. The universe is contained in page 1 of Google. So there aren't any other languages that can do this. We can't even, think about it anywhere else. So D at least has a hope. How? I'm not sure. This is going to be interesting. I mean, as a human, I can look at enable if and figure out that this is a template constraint. Can I write a program to do that? I'm not sure. I can hack around the C++ standard library. So we're doing this at work right now because we have some code written in C++. We want to call from D. So we're just ignoring boost in the standard library altogether, saying ignore this namespace, ignore namespace stud, ignore namespace boost, just hand me everything else. So what we do is, in this case, there's a function that takes a reference to a const vector. We ignore it, there's vector nowhere, and then we declare vector ourselves like this. So and then obviously the member function. And this works reasonably well. I'm speeding up now because I'm running out of time. Well, I'm nearly the end anyway. So, in conclusion, programming is about the beatbacks, okay? The apes ruin everything, but we have to work with them. So, if we don't take them into account, it's not going to work. If you're arguing, you're losing, so don't argue. Just make an easy transition for them, and it will be much more likely to get adopted. I've tried to out C++ here. I'm trying to replicate what it did to succeed the way it did, and be partially successful. And go forth and include.
All right, guys, you know the drill. Raise your hands if you got a question. I think Stephen over there was first.
So I saw you had line numbers starting at 53. Have you considered putting pound line into
that was just for the test. That was just for testing purposes. So the test will take the C file, translate it, take that decode, write it into a file, and then run the compiler on it. So that's the result of translating. That's what those liners were.
So when you actually call DPP on a file, it gives you the original line numbers from the C files and the.
Oh, I see. Yeah, that's interesting.
All right.
Yeah.
Right. There's a very similar problem in like Python, for instance, where you have the exact same problem. You want to be able to talk to existing C++ libraries. You want to do Qt bindings. You want Qt bindings. You want to do what you said. I forgot the name of that mathematics library, whatever bindings. Yeah, thanks. And exactly. And so there's a bunch of existing interface generators for API bindings like Swig or SIP on the Python side.
Swig is hell.
Yeah, I know. Believe me. I look at that myself. But is there any hope to getting that sort of technology up to shape because potentially you could get other languages invested in the effort?
I don't know. I'm not entirely sure what the question is.
I mean, is there any hope for? Sorry, I mean, is there any hope for technology like Swig, or does D have to go it alone?
In my experience, no, because we used Swig at work to bind C to Python, and it was a complete nightmare. I mean, the manual work we had to do was off the charts. And again, if I'm a programmer, I'm lazy. I don't want to write anything. I want to tell the computer to do it and have it figure out.
Stefan?
Have you figured out, have you tried to patch libclang to export the functionality you need through this interface?
I'm going to have to at some point. I'm just going to have to send pull requests their way because nobody else is going to do it.
Yeah, that's going to be fun.
Okay. I'll go over there first.
Translating a lot of C++ code, one problem I've really run into is a class that has virtual functions that is basically kept on the heap. And I don't have a good translation for this in D, and I wonder if you've run into this problem.
Class? Just use a D class.
No, I'm on the heap.
Yeah.
Okay. Sorry, I meant on the stack. I mixed it up.
I guess, well, but that would be in user code. That wouldn't be the interface though, right? I mean, if somebody's using that type usually on the stack, you don't have to from D. And even if you do, you could use in place.
It's fine until people start returning it. Like C++ doesn't really enforce memory protection or anything like that.
Yeah, that's a problem. Especially because right now, I mean, even in the latest compiler, you can declare a copy constructor, but the bindings don't quite work yet. So returning and passing by value doesn't work right now.
You can have a class stuck on the stack if you just use the scope storage class.
Yeah, and then in place it, sure.
It seems to me like if you're looking at, sorry, let me restart. How do you handle inlining? Specifically, how do you handle functions that are declared inline and contain the body inside the header? Like, is there any hope to do this without doing the entire C++ compiler?
Well, I'm crazy, so I've punted on that. But basically, my plan was to translate the body. Because I'm nuts. I don't see any other way. Oh, what I've been doing so far is forcing the instantiation. It's the same with templates, basically. So I have a C++ file or C file. I force instantiation there and then link. So that's the workaround I'm using right now. But the plan would be to translate. Because that is a cost, right? That's not exactly the same.
All right. Anyone else? No, looks like we're finished with questions time. Then thank you, Attila, for your talk. All right, so come back here in about 6 or so minutes for your next chance to win a D-Man shirt. All right, I think we're all ready to go. Whoa, a couple of stragglers up the back. Come on, don't struggle. You're not going to be able to win one of these D-Man shirts if you straggle. All right, that's the last straggler. Let's go with a question here. All right, here's another one from Walter's Knowledge Bank. What was the inspiration for underscores in integer literals? Not Java, but there's a hand up there. Correct, it is Ada. So this guy gets a shirt. Woo. All right. Okay, but now we need to get on with the talks here. We have Edward Staniloy. I think I mangled it again.
No,
anyway, he's going to give us a talk about class hierarchy and the like. So round of applause, please.
Hello, everyone. I'm very pleased to be here. Today, I'm going to attempt and put forward to you a new way of viewing the class hierarchy in D. So the way I view it, this is my elevator pitch towards you. The catch is the elevator is only going to take 20 minutes to get to the destination. So let's get going. First, let's talk a bit about the current situation. So as I'm sure all of you here already know, in the D programming language, we have object as the root of all objects. And the main interest of us is that object defines 4 methods. It has toString, toHash, opCompare, and opEquals. And I'm pretty sure that at first they don't strike you with much, but the issue with those 4 is that they predate the introduction of function attributes. So they predate the safe, purity, no GC, and no throw. And also they don't work with qualifiers, right? So we don't see any const or immutable up there. So in order to stress it out a bit, if you have in your day-to-day work, let's say you keep an array of objects and your task is to find a certain object in this array of objects, then you will be hit by a couple of problems. First, the opEquals operator is not able to work with const objects, right? And since this is a search function, it's pretty obvious, and it's always right the recommended way of like passing things with const. As Attila was saying earlier, this is his way of like preferred way of doing things. The second issue is like we don't have attributes. So even though this function has no reason not to be, no throw, no GC, pure and safe, it cannot. But let's say a user is going to define his own class, improved object that extends from object and overrides all those methods. And he adds the function attributes, but still this is not enough. So the first issue is that opCompare and opEquals, they will have to continue to take a const object instead of an improved object, and that's because of covariance. So what covariance states is that a derived class, when it overrides a method, it cannot ask for more from its parameters. It can ask for less, but not for more. The second issue is that toString it has no way of meaningfully implementing a no GC version, since it has to return a string, and it has to be something of meaning to the user, so it's going to probably have to convert some runtime information. It most likely will have to call the garbage collector or try to find some different ways. So it's pretty complicated. There are some more issues. So the first one is the object class also has a static factory method that enables you to create an instance of any class. The problem with this factory method is that it creates a lot of code bloat. In order to make it work, it needs to know the type info information of every class in your program in order to maybe call it in the future. And there aren't many calls in Phobos, for example, that actually take advantage of the factory method. So this should be opt-in at best. The second issue is this mutex field. At first, I didn't show it to you. So object has a hidden mutex field that's implementation defined, and this is used for synchronization. So when you want to ensure exclusive access in a code area and a code block, you would call synchronize, and this will effectively take this mutex. So this has a couple of problems. First, it doesn't play well with immutability and purity. There are, again, few cases where the mutex is actually used, so it should be opt-in at best, because otherwise there are a lot of classes that just take up some extra space without ever using that space. And another point is that because this is a field, it introduces a fragile base class problem. What this states is that a seemingly unrelated change in the base class could possibly lead to hard to discover bugs and breaking changes. So we want to do better. And in order to do better, actually, driving home the point is that we have two design goals. The first one is to allow the user, he or she, to pick the methods that his type must implement in order to best describe the behavior that his type is able to fulfill. And the second one is the root object needs to be able to work in attributed code, as it was the case with the find function. So searching for a good design, we decided to look at other languages, other object-oriented languages, and see how they treat the same problem, right? So what is the way of defining the root class, and what's the interface that this class exposes, and how do they treat the comparison, for example? So the first one that we had a look at was Java. As many of you know, D and Java have a lot in common. So object is also the root of all classes. The object in Java defines the equals, hash, and to string methods. Those are similar to op equals, to hash, and to string, right? It has a get class, which is similar to how we use type ID on classes. And most important, it has a call method that's similar to the factory one. And most importantly, it also has an object monitor, right? A lot of similarity. Looking at C#, though, again, is the root of all classes. C# has a much smaller interface that it imposes on the classes that extend from object. So it only has a to hash, get type, and to string. But the major difference here is that C# went a step further and removed the monitor object from the root object, and it defined it as a separate monitored instance that extends from object. So this is closer to what we want to achieve. The next candidate we had a look at is Rust. And if you are like me and don't know much about Rust, you'll probably be surprised by the next things. So the first one is Rust data types are completely unrelated. So you don't have subtyping and inheritance. The way Rust establishes relationships between different types is by using traits. So a trait is just like stating, hey, this is the behavior that I'm capable of doing. The other name that you are probably most familiar with is the traits are exactly like interfaces, more or less, right? So, and we're doing something similar with introspection and structs, right? And all the compile time features that D has. But we can emulate the same behavior with objects as well. So let's have a look at how a trait in Rust looks just for like completion, right? So you define this trait quack, it states, hey, I know how to quack. You have a struct, and then you just say, implement the quack trait for my struct. And now, yay, we can quack all day. Yeah. So now, my proposed design, well, our proposed design is, we'll have a root class that's going to be an empty object, and this is going to be at the base of the hierarchy. And we'll call this proto-object. And then we'll define interfaces that expose the desired behavior, right? Because it can be argued that at the end of the day, you're only interested in what your type can actually achieve, and you don't have to have it baked into the object, right? So how this will look, we'll have at first a proto-object, as I said, that's going to be the empty class. Then we'll have a synchronized object that will have the mutex field. So if you desire to have this mutex, then you will extend from synchronized object. And then object, as it currently is today, is going to extend from this synchronized proto-object. So what this achieves is it gives us a lot of flexibility going further without creating any breaking changes. So this is pretty good. So how this came to be? Well, Andre had the following observation, as he was saying yesterday, right? So object has two roles. The first one is the root of all classes. And the second one, when you don't explicitly state what is the parent of your class, then that role is taken by object. But object doesn't necessarily have to be the root of all objects, right? So this is going to be taken care of by proto-object, and the code will continue to work because if you don't define a parent, then we'll just leave object doing his own thing. So going forward, the recommended way is to inherit from proto-object and then implement the interfaces that expose the desired behaviors. So in order to replicate the existing way of working with object, we start by defining 4 interfaces. Ordered, which implements the op compare, equals for equality, hash in order to implement the hash method, and stringify for lack of a better name, but we can vote for it, right? That exposes the toString method. So the first thing to notice with the toString is that we opted for a design that takes a delegate that you pass what you want to output, sort of like a sink, right? So this is a way of avoiding the GC problem. Now, let's talk a bit about ordering. Yeah. I tried to make it fit the slides. Right. So before I go into how the interface looks, I want to go through the why and what we did. And I promise this is the most complicated slide, and then we can all exhale successfully. So first, at some point when you're going to compare 2 instances of a class, it's going to get lowered to a call in the runtime. And we'll compare 2 types, class 1 and class 2, and we don't know much about it. And we try to figure out at first what's the most derived part. So we're making an assumption at first, maybe they are somewhat related, right? Disclaimer, this code doesn't compile, right? The first alias is just like I had to fit it in the screen. So now we're looking at a bit of extra information. So we're comparing the pointers to the V table. So if the pointers are equal, then it means that we have the same dynamic type. And if we have the same dynamic type, and the dynamic type is the same as the most derived one that we've previously figured, then we can attempt and bypass the downcasting or the runtime and explicitly cast to the most derived one. So we're able to then cast to our most derived part and then call the op compare. If we don't have this information, well, if the most derived op compare method doesn't take another most derived, it probably takes something else, then we'll leave it to op dispatch. If we are out of luck, so either the types are of different types or they have the same type, but it's not the most derived one, then we'll leave it to op dispatch. So to dynamic dispatch. So in the worst case, when we get to dynamic dispatch, we're going to have to compare 2 proto-objects. We don't know anything about them, so what can we do? Well, the first step is to check if it's about the same object, and then we're done. If not, then we're going to have to do a dynamic cast to an ordered interface, and then call and leave it to the dynamic dispatch, then to a call to op compare, and the argument is a proto-object. So this is the interface. Our interface takes a proto-object. The reason why it takes a proto-object and not an ordered is that most likely in your implementation, you're going to do a dynamic cast from proto-object to your desired type. And if we would have took an ordered, then instead of doing only 1 dynamic cast, you would have ended up doing 2 dynamic casts. So it's more of an optimization. So ordering implies that it forms a total order. What it means is that first, for any 2 objects A and B, only one of the following 3 stands true. So it's either A is less than B, or both A is equals to B, or A is greater than B. And the second one is that it's transitive. So if for 3 objects A, B, and C, if A is smaller than B and B is smaller than C, then A must be smaller than C. So now let's look at an example. So suppose you're implementing your class, a book, and so you'll have a unique identifier, the ISBN, and a format. And the way to compare, because a book is uniquely identified by its ISBN. You don't care about the format, right? So you just look at the ISBNs. I was surprised. I remembered I had an animation here, but apparently it's gone. All right. Okay. So as you can assume, this is going to probably generate some boilerplate for the user. And boilerplate is boring, and that's why we want to aid the user. So in order to do this, we implemented this mixin implement ordered. What this basically does, it's in the most raw form, it goes through all your fields inside your class, and it compares it with the right-hand side, right? So in order to use it, you just like mix in the template mixin, and this will automatically generate the up compare for you. And then this is going to go through your fields, and it's going to compare them. And surprise, surprise, those are not equal. And this is the correct behavior in this current format, because as I said, you shouldn't look at formats, right? But the raw implementation will do this. So again, we thought about it. So what the next step is that it allows you to provide it with a list of the names of the fields that are significant in the ordering operation, right? So now we're telling it, hey, I'm only interested in the ISBN. And now we can see that the comparison is the right one. But there's more. What if you want to provide a custom comparator instead of using our default one, right? So we are providing you with this opportunity. Again, in the list of named fields, you can stick next to the name of your desired field what comparator you should use. And you can use either a lambda or you can give it a name function. Yeah. Got a question?
So floats don't give a total order. And if you go look in one of the scariest bits of Phobos, which is SSE TypeCon's proxy, you'll find that the implementation of opcomp there returns a float instead of an int, because it needs to return nan for cases where things are not, where they're not orderable. And this means that you can do a proxy of a float and it works. Does this support the same mechanism, or could it be extended to do that maybe?
So we thought about that. So just for everyone, so the reason why float is not a total order is because you cannot compare not a number, right? So nan cannot be compared with another nan. The way I would suggest going forward is kind of like replicating what Rust is doing. Got to speed up a bit. So in Rust, they have a partial order, and that's exactly for this. And it states like, hey, we're not a total order, we're a partial order. So it's kind of expresses the clear intent to the user. Okay, so just to manage to go through everything, right? Okay, there can be made a case that most of the time, actually what you want to do is you want to exclude only one of the fields. So out of a list of fields inside your struct, only one is insignificant, or a couple of them. So instead of having to type all the others, you can just type the exceptions, right? So this is the final form of the super cyan here. Okay, so now food for what?
Did you consider using a UDA on the fields that you don't want to do that to instead of this?
No. Yeah. So now another thing is like food for thought, because you kind of went ahead of me here. So based on the same thing, so there are some classes where some types where comparing doesn't make sense, or maybe you cannot cast, right? So you cannot dynamic cast here. So from proto object, you attempt to dynamic cast to the book, and it's not a book. And in the previous example, you would have returned a 1 when comparing to null, which this is kind of like you're saying, hey, I'm greater than the other guy, whereas you actually weren't able to compare with the other guy, right? Because you're comparing pears with apples. So float here would provide in with another interesting feature, because you have two options. Either you throw an exception, like non-uncomparable types, or you could return not a number, and this gives you some extra information. Now, equality, as you will see, the interface stemmed from the same issue. At some point, we will, in the worst case scenario, we'll have to compare two proto objects, and that's why the interface takes a proto object. Equality must respect the following contracts. So it must be reflexive, so any object must equals to itself. It must be symmetric, so if A says it's equals to B, then B must agree with this condition, right? And transitivity. And again, for equality, and in order to aid the user with all the boilerplate that he would have to type on his own, we provide the same thing. As Scott was saying a couple of editions ago, consistency, consistency, consistency. Right? So it implement equals has the same roles as implement ordered, and implement ordered equals except. Hashing interface, again, it's simple. It has all the attributes. There's one catch. The first is like, if for equality or comparison, you can quit early, where the first time you encounter a field that's not equals to you, or with hashing, you have to go through all your fields, right? So I'm not stating anything that's rocket science. I'm just like, don't forget about this. And another thing is like, because now we have a lot of power, you as the implementer, because you can decide if you want to implement the opt compare or opt equals or to hash separately, you must make sure that if you go implement each of them, they must agree. What I mean is if two objects say that they are equal, then their hashes must be equal as well. So don't forget about that. It's a common mistake in object-oriented programming. Again, for hashing, we have the same mixins that aid us. And as I said, the string takes a delegate that the delegate also needs to have all the attributes. So that I just like try to make it fit the screen. In conclusion, we have a proof of concept that it's both flexible and it's able to work in attributed code. And we have ways of reducing the code bloat that the user would have to type. So if you want to check out the dip, it's on this branch over here. And the code changes for both the EMD and the runtime are also in this dip proto object branch on my forks. Thank you for your time. And I hope next time we meet in an elevator, you won't run away. I'm here to answer all your questions.
Yeah, I think we've got... basically got time for one question, so make it a good one.
Okay, one of the core problems with all the functions on object is not that it was done before we had attributes, but that no specific set of attributes is good for everyone. For instance, op equals being const is a real problem if your object is doing any caching, because you may not, particularly if it lazily creates value, because at that point, it won't have created it yet necessarily when you call op equals, and so that object can't make it const. So why would you have interfaces here as opposed to just using templates and looking for the correct function signature?
So the best way to go with this, in my opinion, is as well to go with templates. But this is, we're trying to also improve on the lacking parts on classes and objects. So I mean, I know it's not a sufficiently good answer probably, but it's the best.
I don't see why we need the interfaces at all, because if you just have the appropriate template constraints and the code is templated, then it's a non-issue. It will work as long as the functions match up.
Well, okay.
Yep. All right.
So to answer that question, at the level, it must be understood that there's a tension between generic code using parametric polymorphism and generic code using inheritance and overriding. And at some point, you got to resolve that. You can't, if you sit down and try to do it pen on paper, you're going to realize real quick that you got to choose one or another. You can't choose both. There's no magic that templates can do that's going to undo the type erasure that occurs whenever you convert from a supertype to from a subtype to a supertype. So we chose const there because it seems like the reasonable thing to assume people are going to need. It's not expected that comparing two objects is going to write to them. And I understand that this hurts 90% of our users. but it's obvious that the other way would also hurt 90% of our users. You see my drive, right? So I think we can't have it both way, and we chose const, and we're gonna go with it.
All right, well then that's it for now. Thank you, and round of applause, round of applause. And the next speaker is also a half-hour talk, so we're going to get him up as quickly as possible. So just mingle in this room, don't go too far. All right. I hope you all didn't go too far because we are ready to go. So we're going to kick this off. Alexandru Militaru wants to talk about D for a safer Linux kernel. So round of applause and off you go.
Hello everyone. My name is Alexandru Militaru, and this is my very first talk. I'm very happy to be here. This presentation is mainly based on the work that I'm doing from my bachelor thesis, where I am using the deprogramming language to strengthen the security of the Linux kernel modules. This talk would not have been possible without the great support that I've received from my scientific advisors, Edward and Răzvan, and I want to thank them. D is advertised as a safe and fast systems programming language. We know it's easy to write an operating system in D, and many projects have proven so. We have PowerNex, XOMB, and Trinix. However, we don't know how hard or easy it would be to use D code into the Linux kernel. Why we did do that? Because, believe it or not, the kernel is still struggling with many buffer overflows and other ugly bugs caused by faulty pointer manipulation. Many of these bugs could be avoided if the kernel would be written in a language with array bounds checking and other safety features. In this case, D can be of great use, at least theoretically speaking. To find out how it is really like in practice, we decided to introduce D code in the existing C code base of the Linux kernel. But before doing that, we wanted to be sure that these two files together in a greater object, we had to write a kbuild file where we instructed the kernel to place these two files together in a greater object. As you can see, the D object has a special extension namely OShift. By using this extension, we are telling the kernel build system that this object, it's already compiled, and it doesn't have to compile it anymore. It has only to link it with the others. So we had to precompile our D object, and we used DMD along with the -betterC flag because we wanted to get rid of the D runtime because we can't use it in the Linux kernel. After was fine. About adding a parameter to our module, since almost every function in a kernel module has at least one parameter. So we added one parameter in C and then in that function in D. We recompiled, and when we inserted our module, this wasn't working anymore because of an unknown symbol. This symbol was the global offset table. We thought about trying to recompile with LDC and see if this behavior gets replicated. As you can see, no global offset table, and it worked just fine. We didn't discover why the DMD compiler was inserting this symbol, so in the interest of progress, we decided to move to LDC. And so everything you'll see from now on, it's compiled with LDC. Having the proof of concept done with a dummy module, we wanted to introduce D code in a really hot part of the Linux kernel. But the kernel, it's a huge beast, and there are many parts worth strengthening in it. However, there's no place like drivers. A research published at NDSS 2013 measured different parts of the Linux kernel and discovered that the drivers represent the most significant part in lines of code of the kernel attack surface. Considering this, we thought that porting a driver, it's the best place to start. So we began to seek a suitable driver. In our search, we followed three criteria. First, the driver had to be relevant for the kernel community. The second was the driver had to be easy to test and benchmark. And the last one, the driver had to be of medium size in lines of code. Having these three criteria in mind, we chose VirtIO NetC, VirtIO's Nurture driver. The VirtIO's framework is widely used in virtualization, and VirtIO NetC, it's one of the most complex devices supported so far by this framework. It has 3.3 lines of code, K lines of code, and being a network driver, it's easy to test and benchmark. Having the driver chosen, we wanted to venture to the process of porting, but before doing that, we needed a plan. First, we need to port the data structures and then to port the functions, the driver's actual code. Having the driver ported, we could make the first set of benchmarks. The following step was to deify the code to add the D features in the drivers. And the last step was to assess how the features affect the driver's behavior. So the first step was to port the data structures. We needed the data structures because the decompiler had to know the structs layout in memory to be able to use them. Some structs were defined right inside our driver, but the largest part of them came from the header. As Attila said, the level of branching in the header files, it's huge. And there were many structs to port, and we tried to avoid this step by using DPP. However, we encountered some problems, and we were not able to use it. And in the interest of progress, we decided to port the structs by hand. We thought that porting structs by hand won't be that hard, but 1 month later, we were still porting structs. This for sure is because of the high level of indirection and branching in the header files, but also because of some problems that we encountered. One of them was the empty struct. In C, this struct is an incomplete type, and its behavior is undefined in modern C specification. However, GCC permits this kind of struct, and its size is 0. In D, the size of this struct is 1, and this is great because it's part of the language specification. However, when interfacing with C, this is problematic. Consider the following struct. If struct empty, it's a really empty struct, then the D version and the C version of bigger struct will have different sizes and layouts in memory. So you have to be very careful when you have this kind of struct and you are trying to interface with C. Another problem that we had was when we tried to use bit fields in D code. As you know, bit fields are not, D doesn't have bit fields. But we could avoid that using the bit field implementation from the standard library. Another problem that we had was the fact that we can't introduce a version inside that bit field instantiation. But we also managed to avoid that by using string mixin. That evolve version template, it's returning that string if config something is defined, else it returns the empty string. So we replicated this behavior from C. After we ported the structs, we began to port the function. But after we ported the first function, our kernel was crashing. After some hours of debugging, we discovered that the parameters that were used inside the functions were completely different than the one that were passed when the functions were called. This bit ABI calling convention is that if you have a function foo with A, B, C, then the caller will place the parameters on the stack in the following order. And the callee will be able to access them as in the following figure. However, the parameter mismatch was caused by the fact that modern 32-bit Linux kernels are passing the first 3 parameters in registers as an optimization. We've learned that the 32-bit kernels are compiled by default with the mreg parm equal 3 GCC flag that tells the kernel to pass the first 3 parameters in registers, and if they are more, to place them on the stack. How we solve this problem? We compile the kernel for 64 bits. On 64 bits, the kernel is using the standard System 5 calling convention. That means the first 6 parameters are placed in registers, and if they are more, they are placed on the stack. 64 bits, LDC is doing the same. Another problem that we had was after we ported the first static array. After we've done that, we could no longer insert our module because of an unknown symbol. This symbol is the name of the assert fail function from the C runtime library. We've learned that since we used the -better C flag for compilation, the asserts are altered to call the asserts from the C runtime library instead of the D runtime library ones. And this is great. The will remain undefined. Our workaround was to define our own assert function with a minimal implementation, a call to the kernel's panic function, and a warning message. We prefer this instead of a security breach caused by an undetected buffer overflow. Another problem that we had was when we ported when we wanted to use function pointers in D. We had an array of function pointers that we iterated over it and initialized each pointer with the address of a function. After we've done that, we could no longer insert our module because it had an invalid format. And the unknown relocation was issued. When we looked at the relocation section of that function, we discovered that when the addresses of those two functions were taken, this type of relocation was issued, GOTP-CREL. This type of relocation is using the global offset table. Now let's look a bit at the function that the kernel uses to resolve relocations. It's not very hard to understand what's happening here. This function has a switch that handles many types of relocation. However, GOTP-CREL is not one of them. And this switch will end on the default case, and the unknown relocation error will be generated. So we had to do something to avoid this. Our solution was to create two wrapper functions in D that just return the addresses we needed. And we used them in D like that. And now we had two different types of relocation, PLT32, one that the kernel knows how to handle. And when we ported the first global array, we had this array of structs in C that we ported in D like this. There were many functions that were accessing this array, and one of them looked like this. We inspected the relocation section of this function and discovered that the array access generated, once again, this type of relocation. And we already knew that the kernel, it's not able to handle this type. So once again, we had to do something to avoid it. And here the problem was that this array should have been placed in the raw data section, but it is not. And we don't know why. But we've tried to get it there by using first immutable, and then and the problem persists. Then we tried to use enum for that array, and a type info error was generated. What really solved the problem was to make the array immutable enum, and so a new type of relocation was generated, and the array was placed in the raw data section. Another thing that solved the problem was to make the array enum and specify the size. And this type of relocation was issued again, and the array was placed once again in the raw data section. After we ported the structures and the functions, we had an up and running D-written module. So we could make the first set of benchmark. As a reminder, our module, it's a network driver. So to benchmark it, we created the virtual machine using QEMU and measured its network performance using iPerf3. Basically, we created 3 client-server connections, host to guest, guest to host, and guest to guest, and we sent packets for a fixed period of time to see what bandwidth was achieved. Then we've done the same for the C version of the driver and compare the results. Here they are. As you can see, the D and the C version are almost the same. The D written one has a small decrease in performance between 1 and 4%. But considering the fact that there are still some bindings, that means D functions that only call C functions that could not be ported, this difference is explicable and also fairly insignificant. After we've done the first benchmark, we began to add features in the driver's code. There are some things to do, but we've done some of the most important ones. One of them was to add bounce checking, and this is a big plus for the driver security. Let's have a look at this function. Here, an index, it's magically computed, and then this array is accessed. So simple and remarkably unsafe. To strengthen the security of this kernel module, we had to add bounce checking everywhere this kind of access was done. But how do you get bounce checking when you have the parameter of the function a pointer and this same queue that is accessed there also a pointer? We don't have any information about length. After we analyzed our driver, we discovered that there every struct VerNet info it's allocated along with its queues. So here is the length information that we needed. To use this information, we created the wrapper struct that had two slices, one for the send queues and one for the receive queues, a pointer to the original VerNet info struct, and the zero length array that we used to for container off. Then we've modified the function where those queues were allocated. We declared a pointer of the type of our wrapper struct. We allocated memory for it. And then each slice got a chunk of that extra memory. And then we made the old queues point to the new ones from our wrapper struct, the ones that also have bounce checking. Now let's see this wrapper struct in action. Remember this function? Now it's safe and also has bounce checking. Our change was simple but effective. Everywhere a queue was accessed through a VerNet info struct, we brought our wrapper struct using container off, and then we modified the access to be done on our queues that also have bounce checking. Another thing that we've done was to use templates where C was using void pointers to achieve generics. We had this struct in C that's this is a representation of a device in the Vert.io framework. It has a void pointer that holds a reference to something. In our driver, this reference was always to a VerNet info struct. So everywhere a VerNet info struct was needed, it was extracted in the following way. And this works because in C, the void pointers are automatically converted to any other type of pointers. But this is very unsafe. You can be sure that this void pointer, it's really a pointer to the type you think it is. In D, this is done with a cast. Also, if you don't make a cast, it won't work. So why don't use a template instead of this void pointer and also have the type system on our side? What you've done was to template this struct, and then we made the alias, and then we measured how many casts of this type were done, 13. After we've used the template, 0 casts, all gone, and the driver is also safe. After we added some features, we also made the benchmark. The second one, as you can see, the D and the C version are pretty much the same. There's a very small decrease in performance between 1 and 4%. As future work, it would be nice to use link time optimization because there are some functions that are still in C and the compiler can't inline them. It also be nice if we would write down the issues that we've encountered and hand them to the D community. Maybe we can work together to solve these problems. And another great thing would be to make DPP work, because this would save a lot of tiresome work. As conclusion, D can keep up with C in the Linux kernel, but being through all this process and seeing all the issues, we think it's better to write a driver from the scratch in D. But our project also proved that it's possible to port one incrementally. And a compiler switch for the issues encountered for relocation in special would be very. Thank you for your attention.
Alrighty, and again, we have time for one question, and it's from Walter.
I suspect that the slowdown is caused by, instead of calling functions directly, you're calling through function pointers. That would incur a little bit of slowdown, and they just, completely explain why you're seeing that slight decrease in performance. The second thing is all the issues you had in there are solvable. So I'm going to be a broken record and say I need a Bugzilla for each of those issues, and then we can attack them one by one and get them resolved.
Cool.
All right, thank you, and thank you. Okay, so up next we have the hackathon. Now this needs a little bit of attention from the people, not the hackathon, the lightning talks. And getting ahead of myself. This needs a bit of attention from everybody that is doing a lightning talk. We need you to see Mike, who will be heading out there, just outside that door. No? Okay, go see Mike up the back first, and then he'll explain what I'm about to explain to you. All right, so everybody else, you got 5 minutes. Lightning talk, guys, do your thing. Your mic on.
Sure.
One thing as well, I've got the podium mic turned on, so you don't need to hold the microphone. So if you need to walk out, though, you've got a microphone. Okay? Sweet. So yeah, there are guys that want to standing on the podium, so both of the microphones are on. Cool. I think we're good. All right.
Maybe you need somebody else in front of you. Joseph is in front of you.
I'll still do the laptop. All it is just the browser. Okay,
I suggest in that case you use Chromium, just because I have a bunch of JavaScript blocky things on iOS. So I like it.
Oh, it's up high. All right, everyone, we're going live. Okie dokie. We're all ready? No, we're not. Please take your seats. All right, so we've got the lightning talks happening now, and we do not lie. These are going to be lightning talks. These guys are on a strict 5-minute timer. I'm going to let them know when they've got 30 seconds left. When the time goes 5, I'll yell out time's up. Their mic dies. Everybody applauds. Next guy comes on. And since we got a number of, hold on.
And no questions.
No questions. No questions, unless the guy finishes at 4 minutes, and then you have time for one, but that's it. Otherwise, 5 minutes, you're out. Okay, so with we should get this puppy on the road. We've got Stefan up first. Hit it.
All right. I have a few tricks to debug CTV code, and one of the tricks to debug CTV code is to build your own error stream, which you can then return as a string. If you have this code, this should just work with the two functions. When I compile it, it doesn't. Okay, that's not great. It has to be static assert when it's used out of here, but yeah. But now it should when I add the semicolon. This works. If I do it with the wrong value, I don't want a micro break now. It will give me a static assert. I cannot deal with this, and it gives me the value that it cannot deal with. And when I now want to do the same thing with a float instead of an int, something surprising will happen, or maybe something that's not so surprising. So now I enable the other function, and instead of the thing I want to get, I get an uncaught CTV exception, and it tells me it can't convert floating point values. Now, I have a compiler backend, a complete compiler backend that works fully at CTV and supports floating point. So how do I get these error messages out? Well, there is an easy solution to that. I import a module that I wrote. It's called CTV fpconf. And instead of toString, I have to say CTV D2A, fpconf D2A. I always make that mistake, and I never played Dota. and I can't do that. I have to import the current directory, and I get an unrecognized. Yeah, that's probably what happened. What? Maybe I changed the module name. You want to see what it is? Yeah, it's wrong. Has to be underscore CDV. We do that. No, don't. This is what happens when you don't look at the keyboard while typing. If you're not used to that crappy laptop keyboard, and now it tells me static assert I cannot deal with this, and it gives me the 1, right? When you use printf, it would give you 1.90 whatever, but this thing can correctly give you the floating point values that you actually pass in. If I say 2.3.3, and of course here I have to say the same. I remove the parentheses where? Which one? Oh yeah, X. Not another microbag. And it tells me this also correctly, and this is pretty cool. We can now print floating point numbers at compile time. What is your reaction to that? Do I have a second for questions?
You have time for one quick question.
When are we gonna see CTFE? This work?
Say it for everyone, Ali.
When are we going to see this work in DMD?
This particular thing is not DMD. This can go into the standard runtime. This uses the normal DMD. It does not use the new CTFE. It works currently.
All right, well, you got 5 seconds left, so make it count, or you can just applaud him, whatever you prefer.
Applause! Thanks, guys.
All right, so here we go. We got Reinish is setting up now. All right, let's see how quickly he can set up. I'm not going to time you. All right, so that will duplicate. You're good to go. Please stand by. We are having technical difficulties.
No, it doesn't work. So
Yeah, should be fine.
duplicate, it's okay.
Yeah, it's just duplicate. It should be fine. We may need help here. All right, so it's not happening that lightning quick as it turns out.
I'm sorry.
No, I don't know. It's the dude's coming up here. He can sort you out. I guess since we have technical difficulties, we can do another little one of those games that we've been playing for a D-Man shirt. Woo! No one? All right. Okay, so here's the question. It's a good one. Are tabs evil?
Yeah.
No. You were the first one I heard that said no, so you'll do. Robert, you get a shirt. Correct answer is no.
Correct answer is yes. No.
Hey, I've got the microphone. It's my answer.
This is true.
All right, how we doing over there?
Not so good. Yeah.
All right, we're going from DVI to VGA. Let's bring it back to the 80s. Oh, here we go. Hey, all right. Let me switch back to my timer, and then we can kick it off.
Oh, thank you.
Okay, and your time starts now.
Okay, thank you. Well, I want to present you a recent development of the GC in our runtime. And the most important change for me is that we finally have a precise GC in the runtime, and that means it can scan the heap precisely and detect false pointers for most types. This is implemented by passing type information to the allocation functions and others, but no type information change is available after allocation. That was in the proposed precise GC I presented 2013 on Conf, so it's finally after 6 years. There's some because the change that information cannot change after allocation. The special layout of arrays is implemented into the scanning inside the garbage collector. You can enable the precise garbage collector by selecting this command line option or embed runtime option into the binary by linking this string or the string array into your binary. And for the data segment, we already have since some versions this option, and but this is only available on the Windows. So in addition, we have an open GC registry where you can link your own garbage collector into your binary and then select it via the same option. This is implemented in core GC interface. The interface is defined there, and you have to implement it. You can register it with a C runtime constructor function. It must be registered before the D runtime starts because static initializers might already allocate. But if you never allocate with the GC and you really want to forbid that, you can also redefine this register default GCs function and remove all existing GCs as well. In addition, some optimizations have happened, and my vision of workable interactive application is if it needs 1 GB of managed memory and pauses under 50 milliseconds, then it's fine. That would be a rather good achievement. We are not yet there, but with my test that parses the parser itself 100 times and throws away every AST, that's some of kind of a representative test case. And the baseline with LDC is this benchmark result. Where it's especially interesting is the time that it's spent in the GC, that is more than a second, and the max pause time, that is the time that actually all other threads are also stopped if 300 and some memory is wasted when because we so far only allowed allocation sizes of a power of 2, and we added at least one value in between without changing the other allocation strategies. And so we, in this case, the reduced memory is not that much, but it can lead up to 20% less memory being used. And there is so far mandatory cleanup.
30 seconds.
Oh, okay. So I have to speed up a bit. These optimizations lead to some removal of sweep time and recover time. This is special phases within the garbage collection, going down to about 380 milliseconds. But after that, the big breakthrough here is having parallel marking inside the garbage collector, which brings it down to
that's it. Time's up. Sorry, that's it. Applause, everyone. Sorry? Macro. Just macro. All right, so we got a macro coming up. Let's hope we have better luck this time with the equipment. Got it. Yep. BJ out. And bingo! Excellent.
Advantages of using Linux.
All right. Well, here we go. Your time is starting right now.
Well, I want to talk about type-state-oriented programming introduced in this paper. Well, most people know object orientation if you have like two types which are related. Example, a citizen and a superhero, and the superhero can fly, but a citizen can't. Then you define your method in the superhero, and if you try to call it on the citizen, then the compiler complains. However, what if you have one type, but methods that are sometimes valid and sometimes not, for example, in a file? To know which method you can call requires knowledge of program flow, implementation perhaps of your file class, and, well, you need coffee. So what these authors propose is statically checked states. For example, you have a file class with various states. A file can be closed, it can be opened, an open file can be read, etc. I've tried to make a small proof of concept of this in D. I have a class file, and I have inner classes that extend the file. And I use the compiler to match the state. I use open methods for this. Open methods allow you to define virtual methods outside of the class and then call the method related to the instance, to the type of the instance. For example, if I want to read a file, I use the above method. I initiate the file with a static method. I only expose the file base class, and I have to match the type to be able to use more advanced features. It works, but it's rather clumsy. You also need to pretty much adhere to a design pattern, and well, design patterns are bad, in my opinion. But it's funky stuff, and funky stuff is like the positive way of obscure, so that's good. And well, if you want to try things like this, just put it in production code and see what happens. That's my advice. If you're interested in the full implementation, it's on my GitHub, and the original paper is linked here. Well,
all right. Well, you've actually got plenty of time for questions if anybody has one or two.
Can we go back to the last code?
What this code actually does, we define a virtual method handle on a file. Then with some mix-in magic, we actually call, for example, the open file handle method. It then returns a new, potentially new instance of file, which represents the state the object is in. In this case, if we have a file with extra contents, then we still get an open file back. However, if the file is at the end, then we return an empty file.
All right, still cool. And it looks like we've got Amaury coming up. He's up. You ready to talk? Well, you need a microphone, I assume. Let's hook you up.
Some slide as well.
Are we on? We're on.
The slide to the man with
Okay, the dude has the slides apparently, in which case you're going to want this.
Yes. Back and next, I think I can
Yeah.
figure that out.
It's even like green and red colors if you're really confused.
Yeah. Well.
All right. So when the slides show up, I'll let you know when you can start. Go and do a dance. Do a dance. Come on. I've been entertaining people for 2 days. Apparently, he does not have your slides.
I gave them to you. You told me you received them.
All right, let's schedule the next speaker up while you guys work this out.
Let's change, yeah.
I didn't know I needed to get We'll swap around.
All right, so it was Joseph, right? Yes. Good. My brain isn't that completely shut yet. Yeah, we got the podium mic there, so
Let's see, I wanted DVI. Sorry, DisplayPort. And this should work.
Should work.
I set it up earlier today.
Yeah, there we go. It does work.
Awesome.
All right.
Okay, can you all hear me from here?
Yes, they can all hear you. All right. So you ready to go?
I am ready to go.
Well, then start. You're off.
So, yeah, hi, everyone. I'm Joe Wakeling, also known as WebDrake. And about 2 years ago at Conf Berlin, I made an announcement about snap packages for DMD, DUB, and LDC. So this talk is to basically update you on what's happened since then. So first thing, if you don't know what snap packages are, they're an approach to universal packages for Linux distros. So you should be able to install them anywhere, whether it's, Ubuntu, Arch, SUSE, pretty much anything you like. You can find out about them at snapcraft.io, and there are instructions for installing the snap package daemon on whatever Linux system you wish to work with. There is currently still a package for DMD, which covers multiple releases all the way since 2.076. For DUB, where we just have the latest stable version always available. And for LDC, which is, I think, every stable release since about 1.1. And what this means practically is that on any Linux distro where the snap package daemon available, it's super simple to install. In this case, I already have it installed, but for example, I can, if I want to, switch between any minor version of DMD, and it will just download it and install it. So and not only that, but it will keep me up to date with the latest version of this minor version. So if a 2.080.1 goes out or whatever, that will automatically go up. So this thing will auto update to you. I can, for example, switch to, let's say, 2.084 if I want to, but I could also switch to just say, give me the latest stable version of this thing. Or for example, I could say, give me the latest bleeding edge version, which is 2.086. So if anyone wants to try this out now, I would really appreciate it if you would try out this latest 2.086 version and tell me if it works. So I started putting these things out probably, more than a couple of years ago now. I didn't get a lot of feedback from people in the community, so I didn't know, but about October last year, I put up there was a little notice put up on the downloads page on dlang.org. And then something happened, and I didn't notice this until the beginning of this year because I wasn't hearing anything. But there's now about more than 5,000 users of the DMD package and almost 5,000 of the DUB. What's slightly worrying is that there's only about 50 users of the LDC2 package, and I think that's because LDC2 is not mentioned on homepage, so it's going to go there. The other change that has happened is a wonderful person called Ernesto Castellotti showed up on the Snapcraft forums, was also interested in doing snap packages for D language tools and projects. More about him on his homepage here. And he has got in preparation, not only is he helping me keep DMD and Dub up to date, but he's also got in preparation a whole load of other Snap packages for various tools. So this is all NS does work. The only reason it's not published right now and available for you is a small bit of bureaucracy that we have to go through to make this happen. And when that happens, you'll be hearing an announcement. So please give a thought to using these tools. They should be very helpful on pretty much any Linux distro. And yeah, that's it.
All right. Do you want a quick question? You got about 30 seconds. Quick question. All right, very quick. We got 30 seconds.
Just a quick one. Those active stats, is this thing phoning home to some server and telling the server who's, the number of users that are active?
So I'm not entirely, I think it's going by how many auto updates happen. So by default, it auto updates. Oh, yeah, sorry. By default, it auto updates. But you can turn that off if you are paranoid about who's listening to you and only update manually.
All right, well, round of applause again. And it looks like we got Nicholas now.
All right.
And you're also ready to go. So just give me the thumbs up and I'll start the timer.
There we go. Good. All right. So as you probably know, we're having an AGM. The agenda is here. Please have a look at it. Please discuss it. Because the more we discuss before, the more useful stuff we can get done. Now, on to what I actually want to talk about, which is repositories. D-flat, which is a C# .NET wrapper that I've written over the last couple of months. It's rather alpha. What it is a C# application that reflects on a DLL and dumps a bunch of static methods so that we can call it through the core language runtime. Unfortunately, this only runs on Windows because you can't save generated DLLs for God knows what reason on a non-Windows platform. So what that allows you to do is to call, where am I, test. And that's not what I meant to do. Let's try that again. Is to write code that looks like this. So we declare some C# namespace stuff with the function we want to call. There's still a bunch of test code in here because I have fun on Windows trying to get stuff to work. But that's so class library is the name of the library we want to reflect on and generate stuff from. We create the host with that. Currently, we create a wrapper for that using it's a class at the moment, but that's going to become a struct. Anyway, we can call that, and it works. We can call C# static methods through that. The unpin there is because C# has a GC, and we have a GC, and two GCs don't play particularly nicely together. So currently the strategy is to, when you want to call a C# method, disable the DGC, call the C# method, and then re-enable GC on the other end so that you don't get horrible bugs. There's some notes on why this is the case here. This was mostly just me dumping brain dump of what problems you will have if you don't do stuff properly, and a note of the current strategy of how things need to work. So what this will enable is completely horrible performance of calling arbitrary C# code if you want to iterate rapidly and you have some code in C# that does what you want to do and you just want to use it and don't care about performance because that does lock the GC every time you call it. That's about it. This is very alpha. This will change quite rapidly soon, but it does work. And yeah, any questions?
Yep, raise your hand if you got one.
No questions.
Looks like you're all good. Round of applause for Nicholas. All right, Amory, round two. Oh, look, your stuff's ready now. All right, are you going to stand at the podium or do you want a mic?
I don't know.
Well, we've got options, right?
Yeah.
So if you're standing at the podium, just speak into that. Otherwise, we got this one.
Okay, I think I'm fine. Everybody can hear me, right?
Alrighty.
Okay.
Yep.
So I'm gonna stay there.
Off you go.
Okay, so I'm Maurice Sechet. I'm the lead developer of Bitcoin ABC, which is like a cryptocurrency software you don't need to really care about. I've been in the community for a fairly long time. And today's topic, I want to, make a bit of a problem statement of what I'm not using D more for what I'm doing, and then more problem, and then, that's a lot of problems. So I'm a lead dev of a large application, large-ish. I mean, they are bigger than that, but it's about 200,000 lines of code. It's not exactly modern C++, but it's C++ anyway. It takes, like 1 hour to compile from like a fresh compilation, so it takes forever. There are serialization, deserialization stuff. For anyone that have done that in C++, you know that it's probably preferable to poke needles in your eyes. It has a lot of multi-threading, same thing. This is awful. So DMD would, look like a very good option for me. It's a system language, and I need that because I have cryptography. I need to avoid side channel in all the crypto code. So that means I need to control what I'm doing with the cache and the branch predictor and stuff like that. I can only do that with a system level language. And I also have low latency constraint in some part of the code. And so I need to be able to control things a bit tightly. It has very fast build time. It has a type system that helps me with trade safety. It has also, like, for deserialization and deserialization, because of introspection, you can go crazy fast. I mean, like, I implemented the whole protocol that we have in less than a day just by implementing like a set of function, like, you serialize, deserialize an int, and whatever we have else in the protocol, a vector, and then a bunch of struct, you reflect on them, and boom, you have the whole protocol implemented in less than a day. So that seems like a great stuff, right? But I've only been able to use D for like prototyping, simulation, doing various measurements, stuff like that, but not in the core application. And this is because I have challenges, and they pretty much all fall in the same category, and that category is like weird shit, right? There is weird shit happening all the time with D. So it's not like missing features and stuff like that. Like, people are talking a lot about new features that they need, and I have everything I need in D, right? But most of those features, they're like 95% there, and then the remaining 5%, this is the twilight zone, like stuff appear in there, disappear, like, I don't know, nobody understand any of it, like immutable enums and stuff like that. So we started calling that weird shit because this is very weird. And I want to go through a few examples. So we have compile time feature, they are great, right? But we have like language construct, like static if. We have a std trait that does like half of the thing that you need to do and not the other half. And then you have like a bunch of very bizarre compiler thread that like none of them works consistently. And what is that, right? Like, it's very complicated. Nobody has any idea what, like, we just like copy paste recipes that we have, just like the C++ guy do with templates, and like they unwrap this 25 different series of templates to do whatever they need to do. Okay, so we have type qualifier, they are great, but we have shared. Apparently, the only thing it does is prevent you to increment plus, but you can still do plus equal 1. So you cannot construct any of them safely because you need to construct them thread local and then case them to shared. This is what the spec actually tells you to do, but this is also the spec that tells you this is undefined behavior. And so as a result, it doesn't provide very much guarantee in the type system. So what is that? They support profiling and code coverage out of the box. That is awesome. This is the kind of stuff I need, right? But all the file format that it dumps out of it, they are not like standard file format that is supported by other toolchain. I can use none of the tools that exist, like gprof and like whatever is my IDE and stuff like that. So what? The unit test, D has a unit test block, and this is, honestly, this is the best unit test feature I've seen in any language, especially because of the way it pairs with the way visibility works, like public and protected and private and all of that. It allows me to test a bunch of stuff, and in other language, I have to build weird scaffoldings to be able to test what I want to test. And this is like, honestly, this is like the best feature ever, right?
30 seconds.
The test run before main. Like, what is that? Right? I don't want to run the test and then my application at the same time. There should be like two parts of the build that are different. Okay, we have like optional Node.js. Maybe I have 30 seconds, so I'm going to go fast. It's like there are some weird stuff in there as well. Okay, so I really want to use D. Like, you guys need to save me from C++. This is horrible. There is like even more weird shit in C++, but I don't need new feature. I need like.
And
this
that's it. You're done. Thank you, Amaury. All right, and we've got our GCC hero, Ian, stepping up to the stage. I'll make him feel welcome.
Okay.
All right, let's have a look at your setup here.
No.
Well, it's an adapter. Just pull it out now. Yeah.
Excellent.
Yes, excellent.
It's just what I like. So.
Yeah, there we go. Should be getting something on screen. There we go. All right.
That's not what should be on screen.
No. There, yep, just full screen it. You'll be good.
Oh, excellent.
All right, excellent. So, ready, set, off you go.
Okay. Now, this here is a mobile phone. And let me just log into it. So, yep, this is an ARM64. How many processors have we got? 8 and 3 gig memory, 1 gig swap. Yeah, we have a compiler here. One. And yeah, that tells us pretty much information that we're looking for. So AR64. Let's run the test suite. After a while. And we're passing. Now, I'll stop this in a minute before my phone dies, our battery. But yeah, pretty much, so this will actually pass all to completion, 100% passes, no problem there. Pretty good, although very little that I actually did in order to actually achieve that. It was sort of very much, small bits and pieces here and there. Excellent, you're on the wrong screen as well. How do I move you? I can't move you. Let's do you this way. So yeah, it's really small things that were really sort of very things in the D runtime to really sort of get this sort of stuff working. And as I was porting various architectures, this sort of stacked up, and it's just a couple of lines here, a couple of lines there. Really just sort of show you sort of a few examples, sort of question and answer session. So what do you think is the problem with this function? Yep, Stefan?
The stack grows in the wrong direction.
Yes, on when the stack grows up, pthread get stack is already at the bottom, so there's no need to adjust it. So we add version stack grows down, adjust. Next, why would this assert fail?
Endianness.
Endianness, yes. On little endian, HELO is on the left-hand side. On big endian, it's on the other side. Next, why would this throw a SIG bus? Alignment, indeed, because, well, on 32-bit platforms, well, mutex is a class, so that alignment is wrong, and the pthread may require alignment of 8. So you might get lucky and the first array is on the correct position, but the second is not. So again, fix would just be to have 2 separate global with the correct class instant alignment. Next, why would this seg fault? The external API accepts a void. The internal is actually a struct. So while on x86, void pointer and struct with a pointer are passed in the same way, on some architectures, they're passed differently. Next, why does this have silent corruption? Yep. No. So the for each body is turned into a delegate. Remember, for each int I. This calls this function, which uses size t, and passes the size t as a pointer. Now on Little Endian, all the bits are on the correct-hand side when it gets truncated. On Big Endian, it's on the opposite side, and so the index here is always 0. The compiler should warn about this, and it does for
30
static
seconds.
arrays. And finally, why with this segfault? Strict alignment. That's kind of a workaround, but you kind of get the idea of what's going on. Now, currently in GDC, these are the targets that we support. This is what I want to extend to in the next point release. And these are various, when the came out, these are the compilers that I...
And that's time. Thank you, Ian. All right, so we got Leo coming up, right?
Yeah. Let's see if this. Okay. Can you guys
ready to go?
Yeah.
All right. Then we're starting.
I'll show. Got a few questions about Nix, so I'll show you how I use Nix. And the first thing I'll show is how to add Nix packages to your local path. So nix-env-i installs a package, but only to the local user in the path. So I'll use dir-env. Anybody familiar with dir-env? Yeah. So dir-env is awesome, especially with Nix. So you can say, well, I show you first. I have nothing up my sleeve here, right? So I'll say I want to use Nix. I want to have dmd, dub, and dub to Nix. I create a file rc. Now dir-env is complaining that the file changed, so I allow for this folder. Oh, that is a good one. I'll remove this guy. So dir-env, as soon as you go into the folder, the env-rc file is interpreted, and now I have dmd and dub in this folder. If I go out, I don't have them anymore. That's good. Let's create a 5D project. Everything default sounds about right. So now I can build this. Okay, that works. But now I want to create a Nix file for that. I'll show you later why. I'll do dub to Nix save. It prefetches all the things from the selections file. Prefetching because it needs the SHA-256 for every package. It's not happy with just the version number. So it prefetches a lot of stuff. Okay, there we go. So now what we have, this was a failed, we have a dub selections.nix, and we can actually use that thing. Let me also, actually, I should have done this. Okay, it fetches again. It's not to just have the dependencies. I also want to have the skeleton for the actual application. So with the -o, it creates a Nix file for the actual application. The Nix file is fairly standard. It just imports the local folder and make a dub derivation for the folder I'm in, and I can build that. So I do build default Nix. Aha, so now we're getting somewhere. It fails, and why does it fail? Because the build process for OpenSSL for 5D TLS tries to write in the Nix store, and that is not possible, right? Everything is immutable. You're not allowed to change stuff inside that store. And why is that? When you want to use 5D TLS, it tries to find out what version of OpenSSL you have. And then during the build process, it does an OpenSSL-v and creates a D file with that version in it. But we cannot create anything because that's not deterministic. So we'll tell it to stick to one particular version by using a subconfiguration. Forgive me if I don't align everything. Oh. Why am I doing this in Vim? I don't know. Okay, so we try it again. Nix build. And what Nix build does, it tries to build and then creates a result inside the local folder. Let's see if this works now. This is not the most exciting lightning talk like this. Anything else? Well, I can switch to another thing while that is building. Sure. Oh, time seems to go way slower when I'm up here. Okay, so it fails.
30 seconds.
That's what I thought. It's failing because we're missing one dependency, and so we tell Nix that we want OpenSSL, but OpenSSL comes from another thing, and that is from the official store. So we need this. And this would result in a proper build, but it takes too long. So what I show you can add any native dependency.
That's time. Thank you, Leo. All right, we got our Razvan stepping up to the stage again. Did I mangle that?
Yeah, that's okay.
It's okay. All right, thank you.
So do I have to stay here? I can't walk away from the
If you want a microphone, we can get you one.
Yeah, no, it's fine.
Razvan, there we go. So this microphone also works, I think. Oh,
Pretty. Okay. Oop.
When did you paint that?
Yeah, I don't need it anyway, so.
All right, so you're just going to talk, no
Yeah,
slides.
Can I have them?
All right, is this one on? All right, we should be on. Can you hear me? Nope. Sounds like we need volume still. All right, that sounds like it's working. Your time starts now.
Okay, so first of all, I'm here to talk in the name of the group, D-Lang group from University Polytechnic of Bucharest. So we've been attending DConf for about 3 years, and absolutely every single year we heard talks about how to raise the popularity of D. Usually when we talk about this, we have two perspectives. The one is that what features do we need to add? What features do we need to improve so that we raise the popularity? Well, we agree with Omori. We already have a lot of features that are working okay. So if it's popularity that we're interested, that's not the right perspective. The other one is marketing. We always talk that we need more marketing. Rust has marketing, and look, everybody knows about Rust and so on and so forth, but we don't have the money. Okay, so we don't have the money. We've hit a brick wall. Now, I'm here to present a different perspective, a perspective that we all adopt in Bucharest. Now, since we are all educators over there, teaching assistants or professors, we kind of have this motto that get them while they're young. So, yeah. I know that didn't sound right, but. So the thing here is that we want to try like this reverse strategy. And if we let people know when they're young about this cool language that we like, maybe they will remember, and when they get hired and they're in the situation that Attila was, now that they have DPP, they can push D. And I know that it's kind of a long shot, but what other alternative we've got? So in order to support this, we've been constantly trying to push D to students. So yeah, that doesn't sound really well also. So we've had some projects. Alex also is doing his bachelor thesis on this. And anyway, what I was trying to do is to announce that this year we're holding a D summer school at our university. We want to take like 40 students and show them the wonders of D. And I think that if you guys, wherever you work, and try to support D for the young people, then maybe that's a strategy that will pay off in a few years. Thank you.
There's plenty of time if anybody wants to ask him a question. No, he doesn't want to answer. All right.
Any?
All right, I think we can save those kinds of questions for Beer Conf, hey? All right, give it up for him again. All right, so now we've got our last talker coming up by the name of James.
Hello.
And you don't have slides either?
I don't. Thank you for everyone for putting me in such short notice. You'll have to
let me get the timer ready. And go.
Thank you. You'll have to imagine the best slideshow you've seen today. I'm James. I've spent a lot of time over the last 6 years working with Dee on a number of satellite data processing projects. There is a very interesting kind of satellite data that allows you to track the movement of ships on the oceans. It turns out global shipping is basically a massive IoT network. Ships talk to each other using a machine-to-machine VHF radio communication system, which they yell, "This is who I am. This is where I'm going. This is what I'm up to. This is what kind of cargo I'm carrying," to help captains avoid bumping into other ships. It's a safety of life system, and it was discovered quite recently that the signals can be picked up by a low Earth orbit satellite. So various companies have been filling the sky with constellations, and nowadays you could, if you pay the right people the right amount of money, you can get lovely real-time feeds of kind of order of 50 million messages a day broadcast from all over the globe. And we've moved in a fairly small number of years from a situation where we had no idea what happened on the sea to a really very strong idea. Problem is the engineering, the work to translate this data into useful knowledge is quite challenging. And as the field is so young, it's often rather badly done. So my users, my clients have been primarily in two groups: scientists who want to understand questions like where does the fishing in Europe take place, because it matters, for example, for governments who want to plan things. Or the second group is forensic analysts who are interested in crimes that take place on the sea and want much more interactive tools. But both groups want they both want to do data science, but some of them also want tools with much better latencies. The traditional way you do this is by throwing it at Hadoop. Turns out writing Spark for this kind of writing Spark jobs for this kind of data is very hard to do. A lot of money gets wasted. A lot of money gets wasted on teams that produce systems which produce the right result, but run for kind of weeks and weeks doing not very much. So after a certain amount of time helping people do this, you go, a much better approach is to attack it with efficiency rather than parallelism. The data rate, the data volume, it's kind of in the tens of terabytes range in uncompressed JSON. So it's in that netherworld but it isn't quite big data, but it's too big for standard tools. So you ask yourself, if we want the productivity of Python and we want the performance of C++, is there a language that can help us? D turns out to be an absolutely perfect fit. It's a kind of bizarrely perfect fit, actually, because everything from command line batch processing to where you just want to do a job as a one-off thing, to building infrastructure that can serve up a reasonable number of queries with very, very good performance, D slots in perfectly. The most interesting work, the work that really stands out as a result of the project, is that if you want to build, this is a time series problem. You get all these messages, you project them into a series of representations, each of which captures one essence of the kinds of questions that your users want to ask. So, they might be interested in the way ships move, because that tells you something about the way they do. You basically do ML of that. They might be interested in where they go, because you can pull out patterns of which companies are interested in touching the companies. And you do this by projecting the data into highly optimized, essentially special purpose databases, which you write with very specific data models and chunking and ordering and various particular indexes you write. And you memory map all of that. You say take over a 2 terabyte SSD, that kind of thing, and you memory map all of that and get out ranges of spans of memory map data. which you then put to long chains of range processing, which is what D is wonderful for, and it works beautifully well. It's sort of embarrassing, actually, the amount of correct code, the amount of correct behavior you can get from a very, very small amount of really very beautiful code, most of which has come from the standard library anyway. And you've just added a few more generic algorithms. Your storage engines kind of...
I'm sorry, 25 seconds, by the way.
Thank you. Yeah, anyway, so you use the metaprogramming design the storing engine to make that cheap. So as users come to you with different kinds of queries they want to be able to run fast, you can materialize the databases they need to do that quickly. Then you run generic algorithms over them, but you get to reuse the algorithms because it's D.
Wow, that was a certainly impressive compression of your talk there. Congratulations. Thank you. All right. Yeah, I'll take that. Okay, and that was the last of the lightning talks, which consequently means the last of today's talks and the end of the second day of DConf. So please give all the talkers again today a round of applause. Yeah, all right, pat yourself on the back, Attila. We'll enjoy that. Okay, so well, we got to get out of here by 6 o'clock again tonight, so don't loiter around for too long. Go out, feast, drink beers, be merry. We're in London. Same place as before. It's still on the it's still on the DConf website. In the venue down the bottom of there is all the details about the pub that we have a room booked for. So come along, and thank you again. Enjoy.